Okay, John.
Got it. Good morning, everyone. My name is John Gross with Sensible Technologies Hydronics Specialties Company. And this morning we have Mark Soja from Chiltrix, their lead tech guy. And he's been doing this for a long time, and he's our go-to person whenever we have questions. Um, Now he's going to be turning over the ball to us and more often than not going forward after some meetings. But as far as handling a lion's share of the tech support, but he's our fallback guy. And with that, Mark, would you take over?
Morning, everybody. Welcome to the CX35 and CX50-2 class. We're going to get started today by reviewing the CX35 installation and operation manual. This unit is very similar to the CX34-3 series. There are some components that are different, and we're going to point out those differences during this class. So let's begin. You guys can have access to this manual after the class. It's all been updated as of yesterday morning, and John Gross will have all the copies to distribute at the end of this class. One thing I wanted to point out about these chillers, when you're shipping them, you always stand them up. You never lay them down. And a lot of people ask us why. We could be careful. We can put it on a foam mattress. That really isn't the point. The point is that the refrigeration section can easily damage itself. It's all soft copper, and it was built to stand straight up and not be laying on its side, especially the compressor being mounted on shock bolts. That will bounce and it will bump those pipes, and you'll end up with a pipe sooner or later rubbing against another piece of metal it was never intended to touch. And that's where the problems start with leaks. So anyway, always have them standing up, never laying down. Now going into the CX35 components, these aren't the best pictures in the world, but if you want other views, other shots of this chiller, we have a program that we can remove the covers and zoom in and basically take this thing all apart. So you can email us or me at mark@hotspotenergy.com if you need any more close-in pictures of the refrigeration section, and we'll get those to you. The dimensions are listed on page 4. These are the height, the width, the depth, the feet dimensions. A lot of people ask us about these because they're going to be putting them on the sides of buildings, using stands, all types of different arrangements. And they're very critical that they be accurate. So if you use this chart, you should have good luck with your mounting. There are pads also that are shipped with this unit that aren't really mentioned, but there are 4 pads that are taped to the plastic on the back side of the chiller when it's being shipped. So when you take off the plastic cover, that bag with the 4 pads will be taped to it along with a domestic hot water sensor. Okay, we could start into the piping design. Layout, we're not going to get too in depth. I'm just going to point out some of the basics. We always use a buffer tank when we're using floor loops. This is just for thermal separation. It'll also keep your chiller from cycling. One thing about this picture, there is a pump here. We don't get into the design of the pump on the load side for your floor loops. That's usually done by the contractor with the assistance of, say, Taco or someone else, whoever manufactures the pumps and the controls. But there is one thing that is missing in this drawing is that the FCUs, the fan coils, they also need a pump. And that pump would be right about on that top pipe coming out of the VCT37. So that'll be activated by the FCUs, either one or both. They have transformers with 24-volt signals that come on if you program it to do so. whenever there's a heating or a cooling load.
Mark, can you stop for just 1 second? Can you make the view at least one click bigger?
What were you looking for?
Making the manual a little bit bigger for easier seeing.
Oh, the screen, sure.
Uh-huh.
I'm sorry. Yeah, that's much better.
Okay, thank you.
All right. Okay, so the system's going to be connected with the supply coming out of the top pipe on all of our chillers. In this case, we have a V18 backup heater. This is just a concept drawing. It's just showing the placement of it in the circuit, which is going to be before the domestic hot water G1 valve. Okay, in this picture, we have a domestic hot water tank connected to the supply line through a G1 valve, which basically is activated with an actuator controlled by the chiller. And whenever there's a call for domestic hot water, that actuator will turn 90 degrees. And we're going to talk a lot more about this actuator and how it works and how to test them a little bit later in the manual. But all it does is simply ports the water 90 degrees to the domestic hot water coil. And that coil, the other side of it's going to be connected or teed into the supply, the return line going back to the chiller, which is the lower pipe. So that's a basic design showing domestic hot water, a buffer tank, fan coils, and a floor loop or floor loops. Now, what we recommend for the CX35 is 1-inch PEX, oxygen barrier PEX. You can use CPVC pipe, but you can't have more than 25% glycol. It will cause problems with stress fractures over the years. And when I say over the years, I mean 10 years or more. This pipe will simply fall apart. So oxygen barrier PEX is the best, 1-inch for the CX35. We have a lot of designs on our website in the documents section showing different piping schemes. I didn't want to get too far into it here because it's very vague. Your situation is going to be different in some cases. So what we like to do is before commissioning, send me or John a copy of your drawing or schematic of your piping, and we'll just do an overview and just look for anything that might cause a problem down the road. So do this before you actually plumb it. It would be the best time. Okay, another thing I wanted to point out is on all of our systems, we want to have a Y strainer installed on the return line. This is going to have a filter with number 40 mesh, and that would protect our heat exchanger from particles that come in during installation, things that come up with hard water in your tanks. We see a lot of small things, and these filters will collect those and keep them from entering the brace plate heat exchanger, which could easily clog with all these particles.
Mark, I'd like to add that materials like solder and other things, gravel, can also foul up the flow switch.
Yes, that's a good point. We've found I have found tie wraps, cut tie wraps lodged in a pump impeller, and this installer didn't have a Y strainer, and I know for sure on all his future installs he will. But nobody knows how this stuff gets in there. It could be during the flush fill. It could be dragging pipes from the truck to the customer's house. You're going to get grass, everything else. you name it. You'll see a lot of things in your bucket when you're doing the initial flush fill, that didn't come from your supplies. It could be anything from bugs to grass. So we've seen it all. But the Y strainer is very important. I can't emphasize that enough. So here we're looking at two chillers in parallel, one buffer tank. One of the chillers is using domestic hot water, and they both have V18 heaters. So that's a good overview. Over on the load side of the buffer tank, we're using FCUs, but that could also be a series of floor loops. Your pump would be pumping into a manifold. So we never pump straight from the chiller to a heating manifold without a buffer tank. So continuing on. Okay, on our buffer tanks and domestic hot water tanks, they all have stainless steel fittings, and we get installers from here now and then that'll use stainless steel fittings, and you could do that, but we suggest brass or copper. They tend to give and take a little bit. If there's any slight tiny little imperfections, these fittings will work a lot easier. Along with tape. They're all tapered fittings and ports. So all the ports on this tank, they're 1-inch ports on the supply side. You can connect up to 3 chillers, which I don't think I have a picture of 3 chillers, but it'll look like this picture with these 2 center ports connected to the 3rd chiller. And you can have these in any order. By the way, it doesn't really matter. If you're going to stage your chillers, you're probably going to do it with your set points. They'll all be slightly different. So one chiller will be the lead, and the others will be more or less jumping in as needed as the loads grow.
Mark, I'd be stronger about the statement with stainless steel fittings to the Chiltrix, especially the stainless steel tank. That's the only place where you might cross thread. The tank connection is with a stainless steel male adapter. So always use brass. That's my recommendation there. Always brass.
Right. Yeah. And in the lab, we use copper, but we take them off, we put them on, we move them around. Our fittings have to stand up to the stainless steel, and brass is really good. That would be my first choice. But in a pinch, you can use copper. It does work as well.
Just don't recommend stainless male adapters, please.
I'm sorry, can you repeat that?
I just wouldn't recommend using stainless steel connections into the stainless steel tank.
Right. We've had difficulties with them, so I suggest you stay away from the stainless. Okay, the next picture, pretty much the same, except for one something different with the fan coils being in front of the VCT. In this scenario, these fan coils are going to be used for heating and cooling. This drawing could also be changed to use a G3 valve, where the fan coils, if you're just going to use those for cooling, you would put in a G3 valve before the fan coils and after the domestic hot water. When there's a call, when the chiller's in cooling mode, that G3 valve will be ported just to the fan coils. So you could do it either way, except in this drawing, I want to point out that the fan coils will be used for heating and cooling, and not just cooling.
Mark, and for the domestic hot water, are we calling that valve, the 3-way valve, a G1 or a G2 valve?
We initially started with the CX34-3 series using the logic term G1. So we always referred to the valves as G1. In the CX35, that logic term and physical connection is now G2. But if you want to talk about a valve for domestic hot water, you can use the term G1 or G2. We'll know what they are. We're kind of in the middle of transitioning to G2. So you may hear me say talk a lot about G1 valves, but I'll try to mention G2.
And then for point of clarification, G3 is another three-way valve, but we use that for our summer and winter switch.
Yes, there's a section in this manual that we're going to look at that explains a little bit more about the seasonal switchover valve, which is known as G3. And that G3 is also the physical terminal connection on the chiller. So G2 being domestic hot water valve, G3 being a seasonal switch valve. Your installation for your pipe, this is critical, especially in cooling mode. We get a lot of people that give us feedback about how they didn't seal the pipe connections with tape. Anytime you join two pieces of insulation together on one pipe, there's going to be a seam there that has to be sealed. Otherwise, humid air is going to get to that pipe, no matter what type of pipe it is. If it has cold air in it, it's going to start sweating and it's going to make a mess. So you do want to use the higher quality pipe insulation. And one company that I put up here, Armacell, they may have been bought by K-Flex, but there's a lot of them out there. So don't go cheap on the insulation. No Home Depot stuff. We're going to use the better quality stuff, and it's all going to be seamed and taped at anywhere there's a change of a fitting. Okay, so we're looking again at basically the same drawing. I'm not going to go over it again. There are some messages in here for our design guide. If you want to look at chiller options, different drawings, it's going to be at the Chiltrix document site under chiller-options. It's a PDF. It's mentioning to submit your design to Chiltrix for approval. You want to do this before you start piping. Okay, I want to talk about ports on these tanks. The domestic hot water, you're gonna add an element to these, whether you're gonna use it or not. And always open the doors. There's 4 to 6 screws on the doors to the elements. Just make sure that whatever door you're looking through, the plug is in there and it's tight. These don't come tight from the factory. They're semi-loose. They're just snugged up, but they're not there to hold water. So again, all of our ports for domestic hot water and the buffer tank backup elements, you want to check them to make sure that there are either plugs or there's an element in there.
I like on the element, so if you get a DHW 80 or DHW 40, there is a hole there for the element, and we supply that separately, and it must be installed. It is the standard screw type element hole, even if you don't use it.
I caught the middle and the last part of that.
Okay, yeah, to emphasize what you said, Mark, we supply separately the electric element that will go into the hole where the element goes. Whether you have to have it in there, no matter, even if you don't use it, it is there to be a plug.
Right, that's correct. I'm not sure when we started with these tanks that they may have come with elements. We've gone through some different changes in the tanks, but always look behind there. I think John's correct that you are going to have to add an element just to plug the hole. And these elements are standard elements. These are things that you can get from a Home Depot. they're all basically the same, different wattages. So yeah, that would be a standard size hole for the element, and that includes the buffer tanks. Okay, over on the next page, we like to do head calculations if your circuit is a little bit bigger than the average. A lot of guys will add booster pumps to them and just wing it. I like to measure the pipe as it's laid out. It gives me a better idea. You could do a rough calculation on the circuit head, and then you can actually see if your booster pump, which is identical to the pump that's in the chiller, will cover that additional pipe head. So if that's not the case, or if you're looking at the load side, like this is from the buffer tank, you could use a fixed pump, but you have to have the right amount of pump head or pressure to get proper flow to each device on that circuit. So some people, they'll get a rough estimate and they'll buy a 3-speed pump anyway. That would be my favorite. They're not much different in price than a standard speed pump. But this will be your choice, whether you want to use a fixed speed pump on the load side or one of our booster pumps. If there's a need for a booster pump between the chiller and the buffer tank, we definitely recommend a variable speed pump. We sell the Grumpus pump, and we can sell a Grumpus pump identical to the one that comes with the chiller with fittings. So if there's a need for it between the chiller and the buffer tank, we'll be able to supply one. They're also, while we're talking about the booster pump, they are wired in parallel, and they're plumbed in series. So you'll get more pump pressure, but the same flow, but more pump pressure by piping them in series. And the control will be the same as the chiller's pump when you wire them in parallel. They'll both run at the same speed. So at the bottom of this page, there's just some examples of measuring the loop's head, total head. If you ever need any help with this, you can write John or I an email, and we'd be more than happy to step in and either review your calculations or go ahead and help you with calculations. Okay, since we're talking about head calculations, we're going to talk about the loop volume. The volume of the loop is a minimum of 15 gallons. If you don't have 15 gallons, you'll want to use a tank. And that could be one of our small buffer tanks where you're not going to use it as a buffer tank. You're going to put the supply in to one port, and on the other side of the tank, you're going to have the other end of the supply. So it's basically going through the tank itself. It's not going to be, it's going to be in series, in other words, where all it does is increase the capacity or the volume of the loop. We do this because we don't want the chiller to cycle. We want it to run for 10, 15 minutes and then turn off for a little bit of time, not just turn on, off, on, off. Since we're talking about the volume of the tank, I want to mention that there is a thermal expansion tank built into the chiller. It's a 2-liter, and it's pretty good size for a normal sized loop. But if you have extended lengths and you're going to be putting in a booster pump to get to the buffer tank from your chiller, I would go ahead and add up that volume and then include the buffer tank and use a calculator. These calculators are online. I included one here from West Tank, but you can use anybody's. Amtrol has a good selection. Whenever you're thinking about putting in a thermal expansion tank, just remember there's 2 types. There's a regular expansion tank for a well, and there's a thermal expansion tank for heat and cool. You always have to use the thermal expansion tank. All these tanks, including the one in the chiller, are going to have a Schrader valve at the bottom of them. And you're going to set that pressure of that bladder tank to about 2 to 3 pounds lower than what you end up with for a system pressure. Down here, we have the minimum loop pressure is going to be 14 PSI. The maximum, I'd say 43 to 45. The ideal pressure that we use in our lab is about 30 pounds. The lowest temperature, it can go lower than 44 degrees and go very close to 32. As long as you have the glycol in the system, you should be fine. Just check the rating on your bladder tank. I think they all go well below these numbers that I'm using in this document.
Mark, I believe we did some calculations on the capacity of the expansion tank that comes with the Chiltrix. It usually is around 25 gallons it can take care of. So in most cases, we have an extra expansion tank, just smaller than you might imagine, because 25 gallons is already taken care of by the one built into the Chiltrix.
Right. That's a good point. Normally, like I said, on just regular size houses that don't have extended loops where you need a buffer tank, our 2-liter works out pretty well. We're going to find out during the commissioning. If it's questionable, what we do is we're going to start off the commissioning with looking at the pressure gauge on the back of the chiller, and hopefully it'll be very close to 30 pounds. And then we're going to put it in heating mode, and we're going to run the chiller right up to its set point. And we're going to take a quick look at that pressure gauge. If we see more than 5 pounds on that pressure gauge from where we started at 30, then we may want to consider a second expansion tank. And this could be anywhere in the loop, except don't put it in front of a booster pump. Always pump away from an expansion tank. So it could be on a return side. It could be just anywhere, because this is just an expansion of water, but you'll create a pressure drop if you put it right in front of the pump. Like to add, a lot of these tanks have fittings a lot of the air separators have fittings for an extra expansion tank. There'll be a 1/2-inch port under the automatic air vents, some of the bigger ones. And that's for this expansion tank to hang. And these, since we're talking about the air separators, they're called microbubble air separators because all they do and all they're designed to do is just catch the microbubbles that are generated during the heating season and send them to a vent at the top. It could be a manual vent where you unscrew the cap and push on a Schrader valve, or it could be an automatic bleeder that has a float inside. The choice is yours. Put it where you can access it for maintenance. Okay, down here is a picture of the Y strainer. There's a couple different styles of these. We like the brass ones. And a lot of the guys say, well, we like to put ball valves on each side of that and for maintenance. And that's really a good idea. But you have to remember that once you clean it and drain it with the ball valves closed, you now have an air pocket. Okay, and that air pocket is going to travel through the chiller and end up in the worst places like the pump or the flow meter. So it's a good idea to put in the ball valves on each side so you don't have to drain the loop excessively, just the volume of the Y strainer. And but you still will have to do the flush fill. And the flush fill is something we're going to discuss a little bit later in this class. but very important. These have to be cleaned, especially after commissioning, maybe a couple weeks later. If we note your initial maximum flow during commissioning when your compressor first turns on, and then you call in later with a problem of say a P5 or another error that points to water flow, we're going to look at that maximum flow. And if it's lower than you commissioned and nothing has been changed, we're going to point at that Y strainer and ask you to go clean it first before we go any further. Okay, again, here's a picture of one of the microbubble air separators. It has the two manual and auto vent on the top. One thing about auto is these are brass, and I noticed the one in our lab, it works very well, but every now and then a drop leaves the auto release cap and travels down the side of it, and ours ended up being covered with patina. I mean, it looks like an antique now. It still functions, but just want to warn you that the auto vents sometimes will do that. I think some of it has to do with your water quality. Where we in the lab we use a lot of experiments with just straight water. So anyway, the Grumpus pump that we send with the chiller, this is the model number of it, and this is the pump curve. So you can see that with this particular model, we're going to get 10 gallons per minute with about very, very close to 43 feet, 42 feet. It's going to vary slightly, but that's a very strong pump. So we normally, we're going to be looking for 10 gallons per minute on the CX50, but these work the same way on the CX35. And we can go ahead and start talking about glycol now. We sell a corn-based glycol that's food grade, but really any propylene glycol will do. Never use ethylene glycol, like the stuff you'd pour in your car. I believe it's against just every law out there. It's not good for the seals. It's just propylene glycol has the inhibitors that you want in your system, and you want to stick with it. A lot of people say that, well, I live in an area that never freezes. Okay, that's fine, but still you need at least 10% glycol. With these new chillers and the new lower set points, you can approach 32 degrees in cooling mode. And while that's fine if it's above 32 degrees or even at 32 degrees with 10% glycol, nothing's going to happen. But if something were to happen to your flow meter and your pump or a Y strainer, and you're not detecting flow, that could actually slush up on you and freeze the system. So especially if you just have water. Another thing about glycol is we've had customers that will drain their chiller and only use it for cooling. And then during the winter, they'll drain it. Well, there is a drain spigot at the bottom of each chiller that you have to use. It's a 1/2-inch drain. And also you vent the braze plate heat exchanger to get all that water out of it. If you don't do this and you just disconnect the pipes and put it aside with just water in it, it will freeze and it will crack the heat exchanger without you having it plugged in. So be very careful with the glycol. These are cooling charts with percentage of glycol. We have the CX35 cooling mode, top left corner. You could see as you increase the glycol percentage, the minimum pump speed. Well, I shouldn't say minimum. This is for maximum BTU transfer. which it's very rare that you're ever going to have maximum transfer, because if you look at the heating charts that are on our website, you'll see that the call for maximum BTU is going to be at a lower temperature, and that is going to be derated. So you're not going to see, for example, 50% glycol, 24,000 BTU, needing 5.4 gallons per minute. You'll never really see that. We put this up as an example of how the glycol will affect the flow rate. That's really all it is. It's not specs that we use. It's during the initial commissioning that we're going to look at your highest pump speed. At that time, you'll have glycol in it, hopefully. And as soon as that compressor starts up, that pump is going to go to its fastest speed, and that's where you'll see your maximum flow. So these are the two systems with the cooling and the heating calculations done for the different levels of glycol.
One more note regarding the glycol. In our area, in the Bay Area and most of California, we have about 10% glycol, so 90% water. One thing to note, which is important, is the inhibitors that come with the glycol in order to be effective, the inhibitors need to be at 20% glycol. But when we use only 10%, that means we need to add some inhibitor along with it to take care of it. The glycol, the 10% takes care of the freezing part, but to fortify the inhibitors so it doesn't become acidic, add a little bit more inhibitor to the system.
That's a good point, John. We in our area on the East Coast, Virginia and North, we would never go lower than 20% glycol. It would be foolish. Our winters are just very different here. One year it'll be mild with no snow, very little freezing. Other years it'll be the Arctic blast that you see out in the Midwest affecting us. So yeah, I think it's a good idea to add those inhibitors if you are in that area of 10%, or again, add more glycol to it. So actually, today we just went through the remnants of a hurricane this morning when I woke up, and I was thinking about that, about my well house and everything being locked down, because you never know when the weather's going to change. As you guys saw, different patterns out there on the West Coast. So anyway, moving forward, let's see. These are the clearances. This is a chart that you can use, but I want to point out some problems that I see with it. One of them is going to be the picture in the top left corner, where they show a retaining wall just what is it, 8 inches away from the chiller. Okay, that's because that's the minimum for airflow. Now, anybody who's worked on any of our chillers knows that that's the side panel where the pump is, where the flow meter is. You need access to it. And I don't think I can get in there with 8 inches. Most people can't. You're going to make it very difficult if you come that close to the chiller with a wall. And I just want to say it will work. Technically, it will work, but you're going to have a really hard time working on the pump or the flow sensor, or really anything on that side of the chiller. Also, the back. The back is 350 millimeters, which is 14 inches. Now, if you have 8 inches here and 14 inches there, and your fittings for your gauges are on the lower left corner in the rear, the right corner, that's going to be very difficult to work on. I don't know how you're going to do it unless somebody hangs you over the top of it. But again, just pointing this out because these are official air clearances, not people clearances. So try to
Well,
avoid anything on this side, on the right-hand side, getting too close where you can't fit most of your body through there.
so Mark, what would you recommend? Something like 18 inches? What's
Well,
same as
yeah, that
installation?
18 inches is a good number to use. I like 2 feet. But you know, sometimes you just can't do that. Um, if if it's a problem, it's not going to be something that we can help you with. If some homeowner insists on it, it just needs to be explained to them that, you know, it's okay. They saw it in the book as 8 inches, but really, if you're going to get back there to do any service, it's going to be almost impossible. So, you know, again, that's going to be the installer and the homeowner and the architect. We've seen some things out there that don't make a lot of sense to us, but to customers, it's very important. So anyway, that's pretty much the front of the unit has to have a good 40 inches. And I say the more the merrier, but that's in case you want to put up a wall for a sound wall. That's a good number to use, 40 inches. And people build damper walls for noise. Most of them are in California for whatever reason, but those are the numbers that we'll stand by.
Mark, let's go back to that upper left picture again. We had an installation ADU where they installed it, the Chiltrix recessed into the structure of the house. And the amazing thing was that it also became like if you go to a rock concert or some sort of vocal display of music, they have a shell which projects out the sound. Well, that's what it kind of does if you have it in this installation where it's encapsulated like the left and the right hand side of those pictures there. So we had to derate the fan speed just a little bit to bring the sound down so the neighbors would be happy.
Well, again, you know, we've had these installed in the strangest places. I've had a guy that put one on a slide, and he's using flexible piping on the rear, and his power came in just it was a loop, and he would slide his chiller out. Um, I don't recommend doing anything like that out of the ordinary unless you are an engineer and you can suppress the vibration somehow. But you know, as far as I go, I stand by this drawing here and what they're telling us for airflow. I can't really tell people that you can't do this within 8 inches of a wall or the 14 inches in the back. So
Say, Mark, I have a question from admin. How high above ground level can this unit be installed?
how high above what level is it? The ground?
Ground level.
Oh, we there are people that put them on racks on the sides of buildings. They'll stack them where they'll put 3 feet. They'll put one 3 feet up on a rack that's bolted to a cement wall, and then they'll put another one 3 feet above the top of the first one. And the only thing you have to be cautious about is when it goes into defrost, you have to have plugs on the base in the base of the unit where the drain hole is, and you have to pipe that water around away from the other chiller below it. We've had them just mounted in very strange places, but they do make mounts, wall mounts for these chillers. So
Okay.
there's no minimum. You can put this on the ground as long as you have some drainage for the defrost cycle, and of course just regular weather. More of a problem that we see is putting them under an overhang where you're going to have a lot of snow falling on it. In that case, we request people to build just a rooftop, just the roof, just to deflect the snow off it, because it will affect the operation of the chiller if all that snow falls off the roof and gets behind the chiller or the sides and blocks the airflow. Your chiller will stop. So yeah, nothing on the minimum ground clearance other than drainage. And there's no maximum on how high you want to put these. But the higher you put them, the more service issues you're going to have. It's not really good to work on a ladder, if you're trying to refill one with gas, because you either have long hoses or you're going to have some type of scaffolding that you're going to need to put all your equipment up there. Okay, so the pump. This is very important. I put this section in here and made several points that I hope you guys take them serious. First of all, when you get your chiller, the pump's going to be in a separate box outside the chiller. The rubber feet are going to be in a baggie with the domestic hot water sensor on the back of the chiller. So when you get all these parts and pieces, just put them to the side. And the first thing you're going to do is take the cover off the right-hand side of the chiller and look for the spacer in the middle picture. That spacer's there just because the pipes are going to be not flexible. They're fixed, but they don't want them moving. So they have to put that spacer in there. So the first thing you want to do is you'll see insulation on the pipes below the fittings and above the fittings. You want to slice that and peel it back and let that fitting, as you unscrew it, you want that fitting to slide up that pipe. Once you get the top, do the bottom one, slide the bottom fitting down onto the pipe. That spacer should pull straight out without flexing these pipes. If you flex this pipe and you develop a crack at the bottom pipe in particular, that goes to your heat exchanger. That is a stainless steel to copper braze. It is not an easy braze if you crack that pipe. So it's well worth following the directions and slicing that insulation and get the brass nuts out of the way. So the spacer comes out by sliding straight towards you. The pump is going to slide in, pushing straight into it. No bending of the pipes. Can't stress that enough. Are there any questions about that?
And you're going to reuse the washers that are in the spacer for your pump.
Yeah, you can use the white plastic ones. I'm not sure if the pumps come with the rubber ones. I think they do.
No.
Is that they don't?
No.
Okay, I'm going to make a note of that and find out why.
Okay.
Yeah.
We'll use them if you send them.
Well, I know the white ones work.
They do. They come with the spacer.
Yeah. And same thing as the flow meter. They have the white spacers, also the gaskets. So I'll make a note of it and I'll find that out for you. They're probably just for the booster pumps that we sell. The rubber ones, that is. Okay, so as far as the placement of the pump, we're going to follow those directions. And then now we have to wire the pump. This is something that some of the guys tend to be in a little bit of a hurry, and they'll cross these two cables. There are two black cables that come with each pump. They're usually plugged in to the pump. And one of them is going to have three wires, a blue wire, a brown wire, and a green and yellow wire. That is the power cable. Don't get it confused with the data cable. If you get these two crossed up and you're applying 240 to the controls, you're going to burn that pump up. It's not going to work, and it's not going to be covered under warranty. So this drawing here, or this picture, points out where the blue negative and the brown positive connect. You don't want to cross those either. It's polarity sensitive. It's a PWM signal, so it's a data signal, and it won't work if those are backwards. And this is, oh, by the way, this board that we're looking at, this is also used in the CX50-2 that you'll see out there. It's the same exact board. Again, I'm showing the two different cables, the pump power wires and the pump control wires. There's a picture right next to it to the right that shows PWM1 and PWM2. PWM1 is always your pump, the blue and the brown wire. The other side, PWM2, just happens to have a V18 connected to it, which is also a PWM device. And coming down for the power, you're going to connect your power C4L and L2, or in other words, that's L1 hiding behind C4L. It's a control term. So it doesn't matter which wire goes where, in this case, for the pump. And then the ground is shown being brought over to the service block where the power comes in. That's not absolutely necessary. If you want to put in a self-tap and screw that goes into the metal cabinet under the terminal strip, that's fine, because the ground is just a frame ground. So that means that anywhere in that cabinet, you're going to have access to the metal. That's the same ground. And it's not a current carrying conductor that we use. It's a bare wire ground. A lot of these won't be bonded to the neutral at your box, but if they are, don't worry about it. It's still just, it's a frame ground for safety. It's not for current carrying. So that pump can be grounded anywhere on this frame. What I like about the chiller is when you're going to connect the electric to it. In most cases, you're going to use a 30 amp breaker. I know it says 20 amp. I just use a 30 and number 12 gauge in conduit. It's going to come out to a standard disconnect rated for 30 amps, and then into the chiller on that terminal block that we saw on the previous page.
So Mark, on the does say 20 amp. And as far as I know, the CX35 is a full load amp of 14, and I've metered it up to 14. In a lot of cases, we don't have extra space on the main, so we would like to keep it at 20 amp if possible.
You could do that. This is when I say 30, I'm moving around the lab, and we have 50s and 35s there. You can go bigger. It never hurts. You just can't go lower in wire gauge or breaker. So the CX35 will be fine with the 20 amp. It'll work just the same as a 30. But sure, if you have space restrictions, then go with what's on the side plate on each unit. And that would be 20 for the 35. Down below here, we have MOV transient voltage suppressors. I've got a whole handout we're going to look at showing these, how they're mounted, where they're mounted, and where to get them. So we'll be back to that. The next page, these boards have a red dip switch with 4 switches, and the 35 is going to have them all off. The 50-2 is going to have number 4 on. And you can verify this by going into the C parameters and looking at C38. If it's a 0, it's a CX35. If a CX50-2, it's C38 is going to be a 1.
And for everybody, we'll be getting to it in more detail, but the C parameters are the status parameters, and we'll show you how to get into that mode. So we'll get there.
Right. We have a whole section on screens and how to maneuver through the screens coming up. So this is a layout of the board. I tried to ID just about everything that was important, starting with this fuse at the top. A lot of these fuses are there to protect the outputs of these relays, but it also protects the board power. So sometimes if this fuse is blown, it'll be from a device like G2, a G3 actuator wired wrong. It could be a reversing valve that the solenoid on it just fried and took the fuse out with it. So yeah, if you're having problems with any of these outs, then I would definitely check that fuse first. It has a blue plastic cover on it. Just pull it off. Gently pry one edge of that fuse out of its holder and ohm it out. 0 ohms, straight short. Up here is your power connections, your wiring coming in from the distribution blocks throughout the chiller. You're going to see L1, L2, and ground. Whenever you're measuring the system for power, measure L2 and L1. Don't measure L2 to ground and tell me that you have 120 and then you have 120 on L1 to ground. That could be the case, but as everybody knows, L1 is 90 degrees out of phase from L2. So you could have L1 and L1, and if you measured across the two, it would show 120 volts, which means there's an internal problem somewhere. So always expect to see on L2 and L1, 240 volts measured across those two. Down here, this is the plug for the EEV. If you guys are changing boards, it's really easy to get that plug mixed up with the one below it. They're both the same size. Wanted to point that out just in case you ever have to swap one of these boards. Down to the left is the HMI connection. It's a 4-wire connection. And this is your human to machine interface. It's now a black controller where the previous CX34-3 models had the white controller. But basically they're using the same terms, 12 volts, ground, Modbus A, Modbus B. And below it are just some auxiliary terms that aren't used.
Mark, what's the EEV?
Where are you looking?
In the very center, you said the EEV in the middle, and it has.
Oh, yeah, I'm sorry. That's the electronic expansion valve.
Oh, okay.
That there's one. They're different, but there's one for the 35 and there's one for the 50. And I wanted to point out that there's 2 ports for that cable. So that EEV is physically in the refrigeration section down in the lower area. And you could see it using that program I showed you. You can take the covers off and you'll see the EEV. If anybody needs a picture of it, and just in case it ever has to be replaced, I have one of those, and John will have one today. So I'll make a note of that too.
Okay. And by the way, Mark always refers to the HMI, and I refer to it as the interface. The interface is the glowing way you can check the status and change the programs and all that. But I call it the interface. He calls it the HMI.
Yeah, well, and there's a third term called wired controller. So
okay.
It's hard to. I'm going to try to use HMI for the CX50-2 and CX35 because that is the new term for it. The older ones, the white ones, we'll still call that the wired controller. And that way we won't get the models mixed up because you got to remember we're on the phone doing tech support. We're not there. And if we just assume something like, you have a CX33-3 CX34-3 and you think it's a 35, the parameters all look the same, but there's different parameters for each. And we'll get into those later, but yeah, I want to call this the HMI, the newer ones.
Okay.
Easier on logistics. Okay, on for all our systems, there's a system wiring diagram online. I know I'm not even going to attempt to ask you to look at this one. It's just to remind you that they're all online at Chiltrix documents and specifications. They're called the high-res drawings. Okay, so there's one for each of our system. It'd be good to put this on your phone just in case you ever need it. It's a PDF and you can zoom in on any area. This drawing just doesn't cut it for me, but this is what you're going to see on our website, but you can zoom in on it.
I think the most important part of this that's not always talked about is where to put the DHW sensor. It's I think TH7.
We're gonna
Yeah, is
hopefully
that someplace else?
I could find it.
It's probably easier on the other up there. Or
Let's see. No, I didn't list any of the sensors here,
okay.
but you will see them on this drawing on the left-hand side where the green highlights are. Those are all our sensors.
Okay.
Yeah. So the high res drawing you'll definitely see them there. Okay. What we have is when you're using a second non-PWM pump, like a fixed pump or a 3-speed pump, this is how you can wire it. Some people have the need for this. Others, this is controlled by the chiller. And if you set up the parameters correctly, according to what it says below the drawing, it should shut C6 off when the chiller reaches its set point. Okay, so it can be a setup for that second booster pump. It all depends. We put it there because we get so many different applications that are asking us for a second way to configure a fixed speed pump and have it shut off with the chiller being at its set point. So there it is. This is how you do the 120 volt pump, and same thing here for the 240, just a different relay. You never attach a second pump to the L2 and C6L. It's just, you're going to blow the fuse on it. It's not meant for that. It's only got enough current to drive an average relay coil or a contactor coil.
Mark, is the fuse the same on the pumps as it is on what you showed earlier on the board? Is it the same fuse?
Yeah, it's going to be the system fuse that'll blow on this. This C6, we can look at the high res drawing, but I believe it's going to be one of the outs. It's going to be driven by one of the relays, but we could look at that a little bit later.
Okay.
And here's where we get into the domestic hot water G2 valve. We could talk, since you brought up the sensor, let's start with that because a lot of our problems start with this sensor location. We like the sensor location at the top of the tank for just an average user. At time, and everything works fine. You can set the set point to 120 and expect no problems, especially if you're using our tank. Our tank has the proper size coil. It's actually a little bit larger than needed, but we could talk about tanks a little bit later. But I want to finish with this sensor. The sensor, again, comes in a bag taped to the outside bag that covers the chiller during shipping. You simply remove that sensor. In most cases, you're going to have to extend the sensor. So the only way to do that properly is going to be to solder it and put shrink wrap over it. Other than that, you're going to have problems if you use small little wire nuts, because this sensor is basically a resistor. When it's heated up, it gives more resistance. When it cools, it's less resistance. And the chiller knows by reading that number what temperature it is. So again, on a basic installation, we're going to ask you to put it at the top sensor port. Now, the only time that sensor would be lowered to the bottom of the midsection of the tank is going to be if the user needs more hot water, more volume of hot water. So we can move that sensor down, but we're also going to move our set point down. You can't have the set point stay at 118 and heat that water down here to 118, because the water at the top of the tank is going to be a lot hotter. And that's going to cause problems with the chiller on the Freon side. You're going to see P1 errors. So again, if you lower that sensor for a family that needs a lot more hot water than an average family, you got to lower the set point. And where are you going to lower it? I would put it in there, set it, let the tank heat up, and then test the water temperature at the closest spigot with a thermometer. That's the most accurate way to tell how hot your water is at the top of that tank, because that's where it comes from. The port is right at the top.
So I may interject here. When you use a boiler system, usually the sensors at the bottom of the tank, and it doesn't really work in our application with these heat pumps. If you use that bottom sensor for the heat pump system, the bottom sensor location, what inadvertently happens is that it doesn't leave the DHW demand spot because cold water is always down there, and it'll not switch back to your space heating mode. So it's better to have it near the top, so it will see the temperature and then turn off the heat pump for DHW and then go back to your heating and cooling.
Right. Okay, and we've already talked about the placement of a V18 when there's a G2 valve installed in the loop. The V18 will be between the chiller and the actual G2 valve. And that's for safety reasons. The V18, if this valve ever gets stuck, which it rarely does, if it ever gets stuck in domestic hot water mode and you have a V18, it'll at least have water flowing through it until that problem is detected. If you have it on the other side of the G2 valve, there won't be any flow, and that V18 won't know that there's no flow, because in domestic hot water mode, it'll still be pushing water past the flow meter and everything will look normal. So we don't want that V18 on the output of the G2 valve ever. We'll talk a little bit more about the V18, how to commission it and test it a little bit later in this class. So coming down, here's a picture of what I've been telling you guys about. There's the bag. This is the HMI controller right under it. That's the cable for it. You'll notice a green connector on the end of that cable. Don't lose that connector. Otherwise, you can't connect the controller. It's a push-on connector. Over on the left corner, it's giving you the warning about looking at the under the element covers, making sure any unused ports are plugged. They all need to be tightened also if there are plugs, and then it includes our buffer tanks. One customer had asked about using two G2 valves to isolate the first chiller from the second chiller. You may see some drawings with that, but I don't think it's very practical, because one G1 right here, if it's on this chiller, the top chiller, it's going to go through that coil and release its heat. It's going to come back down to the T, to the supply line, and that chiller is going to have its pump running, and there's going to be suction on that side. So there's no way that hot water very hot water from the coil of the domestic hot water tank is ever going to back into the buffer tank, because you could be in cooling mode with that second chiller, and the first chiller was in cooling mode, but now it's switched out to domestic hot water. I don't think you need that second valve here. We have customers that insist on it, and there is a way to do it. But again, I don't believe that that water is ever going to be pulled back to the buffer tank, because when it's in domestic hot water, that pump is running at a good clip. It has to get rid of the heat from the heat exchanger and dump it in that domestic hot water tank. So it's up to the installer. If you want to do that, the option is available. They're basically going to be wired in parallel, the actuators. Again, we're stressing the booster pump being in front of a G2 valve. If your loop is that long, putting the booster pump after the G2 valve, you won't be able to use it for domestic hot water. So we like to put it before the G2 valve. So when the system's running, if that loop is that long, then you need to have the booster pump to be pumping through the domestic hot water tank, just like it would through the loop to the load. There's more on the G2. What we're going to do is look at the way it's wired. The G2 valve is brass. It comes with a plastic actuator, a black and orange actuator, and it's pretty good design. We like it. They last a good long time. Sometimes we get them that are damaged and ship them when they're shipped separate. Sometimes the installers wire them wrong. Sometimes things happen like that. But the way the wiring works with this actuator, it's absolute that the brown wire is connected to L1. The blue wire is connected to L2. It's unlike pump wiring, where we didn't care about L1 and L2. With the actuator, we care about L1 and L2. The black wire is the control terminal. That is going to be connected to G2S on both of these chillers, the 50-2 and the 35. And let's take a look at the actual valve itself. All of our valves, when they make these valves, they punch a T into the stem of the valve. You can see it right in the center of the valve. It's a T. I mark this up because it's hard to see brass on brass as a stamp T. So look carefully and you'll see the T. This T is very important. It's going to tell us where the valve is pointed. If the T is in figure, as in figure number 1, it's pointing 90 degrees to the domestic hot water tank. If it's pointing as in figure 2, it's going straight through to the buffer tank. Now, there's one position that I didn't show. It's not a valid position, but if you look at figure 2 and you turn that valve stem 180 degrees, where that T is now upside down, that allows all 3 of these ports to be open. That's a very common problem we have with installers that run into domestic hot water problems. Because if it goes into domestic hot water, the chiller doesn't know that it's pumping to the domestic hot water tank and the buffer tank. So it's going to be in domestic hot water for a long time. And that buffer tank's going to get pretty hot. So it's really important when you're doing your testing and your commissioning, if there's any issue with the direction of the heat coming from the chiller's heat exchanger, commissioning is the time that we're going to discover that. And you can do this by putting your hand on each of the pipes carefully. If you're in domestic hot water mode, you simply feel the heat going through the top pipe going through the T and up through the top port. And then when it switches back to the buffer tank mode, that pipe, domestic hot water pipe, will cool down, and now the heat will be going to the buffer tank. It's only going to be one or the other, never both. And the last thing I want to say about piping one of these, they're pretty simple to pipe. They come with adapters. You're going to get 3 adapters with each of these valves. These are to change the straight thread, which is European thread, to a tapered thread. So this is all 1 inch, all these ports. So you will see your adapters that come with the valves. The last thing I want to say about this, the heat pump port on the left-hand side in both of these pictures, that's where the chiller supply comes from. It cannot be pumped the opposite, where your chiller supply is on the right. It has to come from the left in this picture. It won't work if you do it opposite, and it'll have to be replumbed. So you'll see an arrow stamped on the port where the chiller enters the valve. I can't show, I didn't see it in this picture, so I drew the arrows on it. Okay, are there any other questions about piping one of these in or wiring the actuator?
I'll make one comment. When you attach the actuator to the valve, the way I have figured it out is there's a big side that has an overhang, and there's a little side. The big side goes on the where it says DHW coil. Always have whatever position you think you might have to put the actuator on. It's the big side goes on the DHW coil side. No other way.
Yeah, it doesn't really matter because the actuator is going to turn 90 degrees. It's going to turn clockwise, 90 degrees for domestic hot water, and then back 90 degrees counterclockwise for buffer tank. So I showed this valve with just 2 holes. Your valve's going to have 4. It's going to allow you to put it in any position, but don't forget the actuator is only going to fit really one way on this valve. And if you start off with it in buffer tank position by looking at the T, putting the actuator on it, that should take off. That actuator is de-energized, and de-energized means that it's in buffer tank position. And you can use any of these holes. I think they put the 4 holes in the newer valves there just to, in case you're in a tight position with that actuator. But yeah, that shouldn't matter because the actuator does one thing and then comes back the opposite.
Okay.
Okay, so let's see. You can read into some of this in case you're having trouble. But if we are commissioning and we're having trouble with this, it's really easy to troubleshoot this. I'll have you put it in domestic hot water mode and then induce a call by raising the set point over the tank temperature. It will go to the valve. We'll feel the actuator turning. At that point, we're going to unscrew the actuator and we're going to look at the picture, figure 1, and we're going to compare it to the valve that we're testing, and it should be exactly the same as that. If not, if you ever have to turn these valves, turn them with the actuator de-energized, or in other words, buffer tank position, and use an adjustable wrench. Don't use the channel locks or vice grips. You're going to tear up the brass. Especially if it's a new valve, it might be a little bit tight at first. Use an adjustable wrench. It fits right over that stem, and it's really easy to maneuver and without damaging the stem. So troubleshooting is easy. Keep this picture, at least this picture, if not the whole PDF on your phone or laptop or wherever you can access it. It's very critical. We all need to talk the same language when we're troubleshooting. And I'm going to be using figure 1 and figure 2. And again, this is just a little more troubleshooting guide. Shows a picture of the actuator. I don't do it with the actuator. I do it at the valve with the T, but you can use these for reference if you're troubleshooting a valve position. Okay, second heat source. This is this second heat source has two meanings. It could be the V18 and it could be a boiler. Okay, what we have here is we're coming off the terminal strip and we're using a relay, and that relay doesn't have to be a double pole, double throw relay. That's to provide power. That would be more like a contactor for a device that needs 240. But that could be a relay with a dry contact for some of the newer boilers to have them turn on at a certain time. And we're going to talk about that programming for that second second heat source as we go through this section here. E2 is the same term used for the boiler application and relay as it is for the V18. That is the logic term, E2. Okay, so down here, it doesn't matter to me whatever choice you make, whether you want to back up your system with a boiler or use the V18. V18 is all electric, so you know, it's up to you. That decision is going to be made at the time of planning out your loop. So there are parameters down here that we're going to go through, and when we actually commission the V18, that's a section of this classroom that's going to be coming up, and we'll talk more about these parameters at that time. The onboard external relay. This is just set up for a thermostat to control the chiller. And when I say it controls the chiller, it's going to tell the chiller to be in heating mode or cooling mode. That's a common setup. There's also a way to make it go into a standby mode, which we don't recommend, but you know, there are applications where people are going to want to put it in standby. So again, this is going to be using this example is going to be using a heat pump thermostat, 2 relays. They're 24-volt coil relays. I don't know if I can get this any simpler, but the thermostat is you're going to use the yellow wire, the white wire, and the common to activate these. So the white is going to be the heating, the yellow is going to be cooling. And if you guys have any questions about these relays, I believe I had some part numbers in here. Yeah, at the top here under onboard external relay, I listed a Tyco K10P-24 relay. Get them with the sockets. These sockets could be just mounted inside the chiller. Very convenient to troubleshoot.
I think the most important thing here is that the C to common for cooling is a dry contact, and the H to com for heating is a dry contact. And it can be done with this relay type of thing or any other dry contact. Say, Mark, what happens if C, H, and common are all jumpered together? I mean, C to common, H to common. The unit runs normally, just depending on the mode, correct?
Yeah, that's correct. That's my favorite mode. That means that the HMI is in charge of changing it from cooling to heating. If you have a thermostat and you're using these relays, there's not much that I can troubleshoot with you on, other than asking you to put the jumpers back in, remove your wires and put the jumpers back in that came with it to jumper COM to H and COM to C at the same time. This is also shown, all the different modes are shown on the high res drawing. It's in a like a green color. I didn't do the high res drawing. I wouldn't have made it green, but you can see it if you focus in on it, the different combinations of these relays that are acceptable to use to change from one mode to the other. But again, I want to point out that here at Chiltrix, we don't troubleshoot heat pump thermostats or your relays. So they're not that difficult to troubleshoot. You could do it with an ohm meter at the outputs of your relays. If they're not shorting out at the proper time, you got a bad relay, bad thermostat, or bad wiring somewhere in there. So pretty straightforward. Now you guys are going to be using the your own controller to control some of these chillers. I've been seeing them become more common. The HBX, is it?
Yeah, there's what's generally attached to these units are HPX, Tecmar, Asana, and now I'm doing lock zone, and we can just apply to this terminal or in the lock zone case to the Modbus.
Right. Okay. So anyway, if there's any questions about this that you have, you can email me if you have a certain design that you want to run by us. I could take a look at it and go over it with you. Again, here's my drawing of the different positions and what you can do with them. You can see where the wired controller configuration is. That's the jumper in place, connecting COM to C, COM to H. The other ones are pretty straightforward. If you remove that jumper, you're not going to do anything. If you have it COM to C, that's cooling, COM to H, that's heating. So the not connected to anything is going to be in a standby, and that's what you want to check. If you're ever in a position where you can't get it to change from one mode to another, or the chiller's just sitting there and you're wondering why, just make sure that that jumper is in place and screwed down tightly if you're not using external control. We see a lot of different things in the field, but when you're troubleshooting these, you're not going to have the answer to every problem. You're going to have more questions for the problems to get to that answer. So being a good technician is not memorizing the book. It's more understanding the book than anything else, and learning. If you don't know how it works when it's working properly, then you're not going to know how it works when it's failing and what's causing that failure. So very important to review this manual every now and then.
I think a good rule is not to use a thermostat directly connected to the wired controller terminal, because sometimes you don't know what kind of crossover can happen at that thermostat. So the relay is the best way to completely isolate it.
Right. And again, if you are going to use the relays or another controller here, do keep the jumper. All right. Don't throw the jumper away, because that's a troubleshooting tool. Again, if you call in and your chiller isn't following commands, then the first thing we're going to ask you is, are you under a thermostat control? If you are, we're going to ask you to put in that jumper or make one. But that's as far as we're going to go in the field for troubleshooting. If it works with the jumper in place, it's not a Chiltrix problem. Okay, also you can look at the C parameters, C63 and C64. When they're closed, that means the jumper's in place. If you see either of these open, then you need to go to that jumper and find out why. It's just something you could do at the controller. And are we ready for a break yet, John?
I think so. You've been doing this now for an hour and a half, and this is so what do you think? 5 or 10 minutes?
Yeah. Okay. Well, we'll be back at 12. Well, here it's 12:40, 45. How about that?
O- Okay, so at 9:45, everybody come back. So Rick, you can pause the recording, please.
Hold on. Okay.
Thank you, Mark. Welcome back.
Okay. What I'd like to do is point out something I failed to mention about the thermostat control. There's also a parameter that has to be enabled, and that is going to be at P111. And I don't think it's in this manual that we're going to be looking at. That page was cut off for some reason, but I'm going to go ahead and correct it when we get to the P parameters. There's two of them that are going to be missing. So anyway, with that said, we'll go ahead and move on. The next,
Mark, can you say again what happens when you change P111?
to enable the DIN 6 and 7, the CCOM and H, you have to enable it at P111 also.
Very good.
Right.
So if we want remote control from a remote thermostat, change P111.
To enable, yes.
Enable. Okay.
Yeah, I'm going to point this out again at the end of the parameters that we're going to go through.
Okay.
Okay. Now, here's something very important. A lot of guys get this right. A lot of guys think that maybe it's not important to have this. This is the flush fill kit that we talk about. We might get into a little more detail about it, but really all it is a couple of T's with a ball valve in between them. Space it real close together to reduce any air pockets. So looking at the picture, we're going to have a transfer pump. This is not to be confused with a sump pump. It's a transfer pump. It's going to have a high head. One of the pumps that we use in the lab is a Liberty 332 or 331. It's not very expensive, about $300, but it's well worth it. If you're going to be setting these chillers up, this is the pump you want to go to, something equal to the Liberty 331. And you're going to have a bucket, with a 5-gallon bucket with some glycol mixture in it. This is after you fill your loop. This is just for pushing in glycol on one side of that supply line. You're going to have the ball valve A closed, so it can only go one way, and that's to the buffer tank. And then we want to push towards the buffer tank because that's the natural flow direction of the chiller. On the load side of that buffer tank, which we'll see a little bit later in the second diagram, you're going to close the load side valves off. You have to have isolation valves over there just for troubleshooting. So you're going to close those. So anything that's pumped into that buffer tank, there's only one way out, and that's back through the return of the chiller. And it just does this. It comes back from the chiller back to the A ball valve, but since that's closed, it goes down through the B ball valve and into your bucket. So that's where you're going to see all the action, all your air, and hopefully no debris, because it's going to, when it comes around this loop, it's going to go through your Y strainer. And so I'm expecting the Y strainer with a 40 mesh to take care of all that, anything that is in your piping or any peripheral device that's attached. So pretty simple, just goes in a big circle, but you have to do it. It has to be pumped from the return of the chiller through the chiller and out through the supply to get all that air out. And don't forget to, if you had opened the air vent for the brazed plate heat exchanger inside the chiller, don't forget to close that. And don't forget to close the 1/2-inch ball valve drain before you start filling. That's a common mistake. It's easy to do. Are there any questions about the general use of the flush fill kit, other than it's going to be on the supply side, pointing away from the chiller? You could have it outside, which is where I prefer because it does get a little messy, or you can have it in a basement or utility room. So we'll learn more about this, and I have pictures of the valves to install to make sure that you have adequate maintenance valves for doing system maintenance. So we'll keep moving along. We're going to actually go through that, and I'm going to tell you how to set your pressure. That'll be in a separate document. Okay, now we're getting to the HMI screen. This is a good page to print out. If you can get color, that's even better, or put this on your phone as just a separate page. Everything is explained, all the icons. So if you see anything that doesn't look familiar, instead of making a phone call, you could just look at your diagram here and get a good idea of what's going on. So I just wanted to point out a couple things that are commonly used. First one's going to be the start button, which is the red poker chip button. It has a green LED up in the top left corner of it. That's the activity LED. If that LED is on, that means that the chiller is started and it's going to start the procedure of heating or cooling or domestic hot water. If that green LED is not on, simply press the start button. It'll ask you to confirm, and you confirm it, and it should turn green at that point. If you're going to turn the chiller off for any reason, use the stop button or the off button. That's the black poker chip right below the red poker chip start button. Okay. A lot of people forget where these are. They're very common to use those. You don't have to start it or stop it when you're changing modes, but if you're doing any troubleshooting, we're going to ask you to stop the chiller. We may ask you to power cycle. So you're never going to power cycle with the compressor running. And speaking of the compressor, right below the shutdown button, we have the pump icon, the fan icon, and the compressor icon. Those are going to come on in order, with the pump on the left coming on first, the fan to the right of the pump, and the compressor to the right of the fan. Once that compressor is on, all three of these should be lit. Unless it's in defrost mode, then the fan won't be on. Okay, and then we have E1 and E2. These will always appear here, but they're not active until they turn red. And when we're doing commissioning on the V18, or if we want to test the hot water configuration, option 2 in the tank manual, we'll see the E1 turn red, we'll see the E2 turn red. They're just indicators telling us that it's in E1 mode or E2 mode. Over on the right-hand side, there's 3 LEDs. The first one's green, power. The second 2 are an orange, sometimes reddish looking. When they're flashing, it's okay. When they're solid, there's an error. That error will show up. It could be a P9, and it could be related to the wiring connection between the HMI and the actual control board inside the chiller. The best way to troubleshoot something like that would be to disconnect the cable behind the controller and bring it out to the board and direct connect it. Several different ways of doing that, but sometimes we have bad controllers that get banged around during shipping. So it's easy to troubleshoot. If it's not the cabling and you're getting 12 volts at the end of your cable, then most likely something bad happened to your HMI, and it's not field repairable. It's a replacement. Down here we have the different modes: cooling, which is always the snowflake. heating is always the sun symbol. Domestic hot water, when the shower head is illuminated, then that means that that mode is available. It does not mean that it's active. Okay, there's other places to look to see if it's active. And then we have AU of heating. That's more like an outdoor reset adjustment. We don't normally use that. We do have a write-up on it in case anybody's interested. It's on our website also, I believe. But if you have any questions about AU, just email them in to us and we'll go ahead and get you the right answers. Okay, one other thing about the HMI, as with all of our controllers, this controller must be installed indoors. Indoors means a conditioned area, no freezing, no rain, no snow, no excessive heat. It's not waterproof. It's not water resistant maybe, but not really waterproof. And I wouldn't say it's water resistant at all. So always put them in the house or in a utility room. If your garage is conditioned, that would be an acceptable place. And that would work for this controller. Are there any questions about the controller and its location? You can go up to 300 feet with an extension cable, but try not to make any more splices than the one that you'll have to make behind the controller, because you have to use that plug. You may be able to just use the wires directly into the plug on the back of this controller. It's completely up to you, but the less splicing you do, the less chance it's going to come back around and cause trouble for you a couple years down the road.
Mark, can you review the left-hand side buttons?
The left-hand side buttons will start at the top with the status button, which gives you your C parameters. You're going to touch that button once, and it's going to show you a picture, a schematic of the screen. And we're going to see that a little bit later in the screen handout. And then there's another button in the top right corner of that page that will allow you to get directly to the C parameters. Now, the C parameters come in handy when there's a problem or a condition that doesn't seem right. You'll go through the C parameters and look at the temperatures of the sensors. Sometimes if there's a problem, it could be a sensor that is working but is way off, causing the chiller to do things that it shouldn't. So when you're ever having a problem that we can't fix over the phone, a lot of times I'm going to ask you.
When you went dove hunting last, did you buy lead or did you buy steel?
I'm sure we bought steel.
Greg, you can mute yourself. I'm going to mute you.
I mean, you can go look around.
There you go. Continue, Mark.
Okay. As far as the sensors go, like I was saying, if you have a problem that isn't obvious to us and we were having troubleshooting over the phone, I may ask you to take pictures of the pages of C parameters and email those in, which in turn I'll do a report. This would be more like a tier 3 condition where after John has troubleshooted with you, and if we're not getting the problem solved in a reasonable amount of time, we're going to escalate it to tier 3, which is me and our engineering group. And they'll look at those pictures, and a lot of times they'll tell us right away what to look for and what to test. So that's under the status button. The P parameters are under the settings button. There's a couple screens you're going to go through. The first one, you're going to select admin after hitting the setting button. It may ask you for a password. And that password for that is going to be 2222. You can't change that. You can't mess that up. Just remember 2222 for the first level password. The admin function is going to, behind the settings button, is going to allow us to get to the P parameters. We're going to see that in the handout that shows you the layout of all these buttons. The next one is going to be the mode button. That's just what it says. It's going to let you pick cooling, heating, domestic hot water, cooling and domestic hot water, heating and domestic hot water. If you have a domestic hot water setup and you go to change the mode to heating and hot water and you don't see hot water listed, that means that it's not selected in the P parameters. We're going to get to those in a few minutes, but that's a good clue, something that'll help you quickly fix problems before having to make any phone calls. The bottom one's going to be your error screen. It's going to have a present and history. Present's pretty obvious. Some of those errors you can reset, some you can't. And the history, you'll never clear the history. Just let it wrap around. It's got a lot of memory for history of errors, and we like to look at them just to see if you have an ongoing problem that keeps showing up, but not in the present screen. The history is a good place to find it. So don't ever clear it. Don't ever try to clear it. John, is there anything else on that? Maybe at the top, we can talk about the LEDs that are listed at the top. The on indicator, the green LED we talked about, it's for
Are
activity.
you still there?
Yeah, I'm still here.
Are my
One more thing is on the very top of the HMI, when there are issues, there's a little screen they'll scroll on past as to what the issue is, just right to the left of the LED fault.
Right, yeah, the fault light is up in the top right corner. That's if you're having any trouble or the chiller doesn't seem to be coming on, that's your first indication of an error, which you'll proceed to the error button. The other ones next to it, Legionella, that's always going to look like it is in this display. When it's active, that black cross will turn into a red cross. The antifreeze, you may or may not be able to see it unless it's activated, but it should come up in, I believe that's yellow. Defrost right to the left of that, that's going to be a blue symbol. It's going to look like raindrops. That means that you're in heating mode and you set off the defrost mode, which is normal to melt the ice off the coil of the chiller. And of course, to the left of that is the shower head.
One more thing is when someone wants to adjust the set point of the heating and cooling, what's the procedure for that?
You simply touch the buttons in the set target temperature section towards the lower middle. It says cool, heat, and domestic hot water. If you're going to change the temperatures to any of these set points, you simply touch the number and it'll give you a pop-up where you can enter your number. And the minute you do that, it takes effect. There's no power cycling. There's really nothing. What you're telling it to do is instantaneous. And that's for all three of them. Up in the top section, right above that, you'll see inlet, outlet, and domestic hot water. Those are the actual temperatures. They're not settable. Same thing with the water flow. That's going to show your flow, whatever it is. Don't forget these chillers. If your chiller compressor turns off and it's waiting for a call for heating or cooling, that flow is going to drop to its very minimal. And all that's for is just testing the water of the buffer tank for any loads that may come on and have changed the temperature of the tank, the buffer tank. It'll detect it by flowing water slowly through it and picking it up. These sensors, the inlet outlet, they're inside the chiller. They're not external. Everything the chiller looks at, except for the domestic hot water sensor, is internal to the chiller.
I would say the standby water flow is generally around 2 gallons per minute. And then when it's actually operating, it goes all over the place, but it's on a CX35 from about 10 down to 5 gallons per minute is normal operation.
Right, and you could detect when the chiller is running its fastest speed by looking at a C parameter. We're going to be covering those shortly in this. I think it's the next few pages, but you can see if the pump is being told to run at a 10, which is the fastest speed, or a 1, which is the lowest speed, or a 0, which means it's just turned off. We're going to talk about pump troubleshooting a little bit later in the troubleshooting section. So we'll learn how to trick the pump out and use the pump speed to determine what it's doing along with the flow. So are there any more questions about the HMI main screen?
I think you covered it.
Okay. So a little bit about settings. Don't forget that the set point shown on the screen is going to be your return water going back to the chiller. The supply water is going to be a lot hotter or a lot cooler. So if these numbers that we're using look a little high or look a little high or look a little low, then don't forget it's the return temperatures, not the supply to the buffer tank. And we put this writing in to try to explain that to you. Okay, so let's go in and start with the P parameters. And okay, so with the P parameters, we're going to use the settings button, and we're going to go into admin. And if the chiller has just been powered up, it's going to ask for that first level password of 2222. And then once you enter that password, you're going to hit the admin button again, and it's going to bring you right to the P parameters. Some of these P parameters are very useful in troubleshooting, and also they're useful when we're first getting ready to commission the system. Sometimes the factory may send these chillers out with different numbers. We know what numbers work best, so we'll go through these and point some of the ones out that are of interest. We'll start with P08. This is the domestic hot water validation. If you set this to valid with a 0, you'll have that mode in the mode selection screen. It'll be DHW, and you'll have the shower head when you select that mode. That P08 has to be a 0 to use domestic hot water, period. Okay, other ones that I'm going to point out, if you guys are making notes, and P27, for example, is maximum percentage of speed of the compressor. This is going to be used for when we first commission the V18, and there is a handout coming up on that. I just wanted to point it out. It's P27 that you can tell the compressor to just don't go any faster than what you set it for, normally 55%. We're doing this to try to cripple the compressor to test the V18, to force it to come on during the summer while you're installing it and not have to wait for winter. So we'll come back to that. Another useful parameter that we work with is going to be the defrost settings, starting with defrost method P34. We're never going to change the method of defrost. It's just telling us that the method is going to be method 1. We have a defrost starting temperature interval, first defrost interval, and defrost exit time. And sorry about that typo, but it's exit temperature. What we're going to do is we're going to leave these at the factory settings. And if you have any defrost issues, an example of that would be when it is in defrost, it's not melting all the frost and ice off the coil. There are areas in this country that we have chillers that act differently in heating mode and defrost, where their humidity is a lot higher than other places, but the outdoor temperature is the same. This doesn't necessarily go off of outdoor temperature. It's going to be based on the coil temperature. We're going to get to the C parameters, and I'm going to point out the coil temperature where you can read that and actually follow the defrost cycle. So again, we're going to leave these as defaults unless there are issues with the coil not defrosting all the ice off it as it should.
About how long is the defrost cycle?
How long? Well, it varies. It depends on your settings. There is a temperature that you can adjust for it to exit. We normally leave it at 35 Celsius. That seems to work fine. That means that coil is 35 degrees Celsius. It could be 0 outside, but that coil has heated up to that temperature. And if that clears all the ice and snow, that's one temperature that we don't want to touch. If it doesn't, we could make it longer to get a little hotter. We've had a lot of different situations, but you know, you're in California. I think you're going to be fine with just defrost. Just want to let you know that they are available to adjust if necessary.
A defrost is something we'd only see in the heating mode.
Yes, that's correct. Because you got to remember, in heating mode, your coil is getting cold. It's trying to absorb heat outside, and it's going to get ice on it after a certain amount of time, depending on how long the compressor is running, how fast the compressor is running. So the defrost cycle is going to be on a little bit more often when it's very cold than if it's just at freezing. So these chillers perform down to -4 degrees. You'll have it about 25% capacity in heating mode. And that's listed on our website in the heating charts, if you ever want to look it up. Okay, so let's go to okay, the pump parameters. They're going to start at P51. This is C4. This is your main pump inside the chiller. It's always going to be set for a 1 EC water pump. P52. We get guys that want the pump to stop after it reaches set point, and we don't do that because the way our chiller knows when to turn on is going to be by water flow. So you always set that to not stop. That just means that it's going to be on that trickle when there's no load detected. It'll be trickling until it sees a load from the buffer tank. Okay, minimum pump speed. This is not to be confused with pump speed 1. The minimum pump speed is only for when the compressor is running. Okay, we don't ever want that pump to run under speed number 4. When the compressor is about to shut off, we want that to still have water flow because we just don't want it to overheat. By not transferring the heat to the buffer tank, it stays in the heat exchanger, and that's what raises the pressure of the Freon. So we want a minimum of 4 here. And a lot of times when we're troubleshooting these P1 problems, we're going to have you watch that number at C parameter 48, and we'll get to that in the next page. But C48 is going to tell us what speed the pump is at. When it gets to a 4, we want to go quickly back to our desktop by hitting one button, the home button, and we want to see what that flow rate is. That flow rate at pump speed number 4 has to be above the minimum pump speed that we're going to be looking at in the next couple of parameters. And then let's see, we have P55 I want to mention. This is going to be domestic hot water E-heater, which is your element. This is the outdoor temperature that the chiller will think about turning on that element. It doesn't mean that if you set it for 20C, that at 19C, that element's going to come on. There are other conditions that are going to activate E1. We're going to talk a little bit more about E1 and E2 a little bit later in this course. So,
Mark, what's the recommended setting for P55?
I would go with 32 degrees or 0C. The chiller should, under normal conditions, be able to handle heating and domestic hot water down to 32 degrees. You can raise that up a little bit in case you just don't want the heat to be off that long. It's all about what your climate is. There are ideal settings for this. Like, again, mine would be 0C or 32 here. Yours may be 40 or 45. It all depends. It'll be maybe a little bit of trial and error, but I do want to stress that the chiller does not absolutely follow this rule. This, to me, means that the chiller is going to start thinking about it, about turning on that element. There's other conditions we're going to talk about, and then there's software revisions that are going to also tell us a little bit more about how the E1 function works. We've just changed a whole bunch of them to make it more easier to control E1. And that version, I don't think you have that version yet, but it's coming. It's already been approved.
Okay.
So yeah, we'll get back to that. Let's see, same thing with P57. That's an activated outdoor temperature for E2, your V18 heater, or even your boiler. So again, it'll start considering turning that function on as long as a few other conditions are met. When we do the V18 commissioning, we're going to go through that commissioning and we're going to fake the chiller out to make it think it's winter, and we'll just picture in our minds what's going on, and I'll explain it during that time, how they all work together. And here's the second heat source starting temperature for your boiler. Same rules apply. P59 is important. This is put here because of the chiller being able to go to a lower set point on the return temperature, where it could get down to 32 degrees in normal operating conditions. This is going to tell you when to activate the alarm. All the alarm means is, do you have enough glycol in your system to go below 38 degrees? Because you're going to quickly approach 32, and you have to have glycol in your system to avoid slushing. Okay, so once we do our commissioning and the percentage of glycol is proper, at that point, we can lower that down to 0 or 32, and you may not ever see this antifreeze error come on. Okay, so it's just an alarm. I shouldn't call it an error. It's just an alarm. And we can basically turn it off with this setting. Okay, virus killing. These are your settings for killing virus. There's a better description of these and numbers in the tank manual. They list out an example of setting your system up for virus killing, or some people call it Legionella. So if we get time later today, we'll look at that tank manual and I'll point these out, but they're all online. Okay, and then flow switch, P64. This is a very valuable parameter for us when we're troubleshooting. If you're having water flow issues, this is where we're going to go to turn the water flow switch off, or the water sensor off. We're going to set it to a 0. That means that the chiller is not even going to look at it. Most of your chillers out there are going to be a 1. That's going to be the black plastic flow meters. You guys have may seen them in the field. The other 2 examples, these are for geothermal systems, not used with us. The 3 was used, but we discontinued that. It's more of a brass flow meter. They may have some out there, but it's not part of this class. And here's another big one. We want to check this at commissioning, P65. This is your minimum water flow, period. When you have the compressor on, it's going to be looking for a minimum water flow, not speed setting, which we have at 4, but a actual flow from the water, the water sensor. For the CX35, it's going to be 9. For the CX50, it's going to be 14. The CX50 manual has the correct numbers in it. But one thing I haven't mentioned yet is this P parameters and the C parameters for both systems are the same, making it easy for us to work with. Where if some of the older guys out there see some of these numbers look familiar, it's because they're based on the CX34-3 model. When they came out with the CX34-4 and the 50-1, they changed all these, which made it really confusing. So that's where it's really important to know your model number. CX35, this is what you use across the board. CX50, we look at the serial number and we determine whether it's a 50-1 or a 50-2. So today we're dealing with the 50-2 only.
FYI, we have only sold 50-2s in this territory, so there are no 50-1s to concern yourself with. There are some 34-4s, so they're kind of the anomaly. So most of them were 34-3s, and now the 35-1s. That's close.
Right, and there's a really quick way to tell the CX34-4 and the CX50-1 is to go ahead and hit the status button. If you go straight into the C parameters, that's a 34-4 or a 50-1. If you get the picture, the schematic of the system in yellow, then that's a CX50-2 or a CX35. So that's a quick way to tell which model you have, rather than going out behind it and looking up the serial number on the CX50. That would confirm it for us to be in that range. But a quick way, a field test, would be just to hit the status button.
Wouldn't this also be in what's the version?
Be in the what?
In the version?
Yeah, the version will look different, but I don't expect the guys to know the version like they would the status, be as familiar with it, I should say.
Okay.
Yeah, version is good to look at when you're commissioning. And if you're having issues that are known to us, anomalies, yeah, that may tell us that you need an upgrade. But I like the status button because all the guys are going to have that right in front of them when they're on the phone with us, and they just hit that button. They can tell us right away. So, okay, let's see. P64 we talked about.
We stopped at P65.
P65. Okay, that's the flow rate. 9 for a 35, 14 for a 50. And then P66 does not apply to us. That's for geothermal. Same thing with P67. So you can cross them off your list. Let's see. P74 and P75, These are only to be used but in troubleshooting. If you ever set one of these, it'll be because we asked you to the guys out in the field. And if you don't set them back, you're going to have a very struggling chiller. So don't ever change those unless we instruct you to. Same thing with EEV, electronic expansion valve settings. We're not going to touch those unless we ask you to. It's always going to be P78 is always going to be in automatic mode, and it'll use P76 and P77 as set points, you can call them. Let's see, night mode. Most of you guys won't be using this. This will just lower the temperature of the chiller for when you're sleeping, if you're in heating mode, just to save a few bucks, I guess, or consume a little less electricity. A lot of people that are off grid will use this. Most people don't. P88, anytime you change a board, you'll have to change this number. Plus the switches on the switch bank have to correspond to the CX35 or the CX50-2. So that's P88. And we don't use 94. It'd be nice to have one, but we don't use it. We don't use 95 that often. We may in troubleshooting. P97, you can force sterilization one time just to test it by setting that to a 1. Virus killing, again, this is Legionella function. If you're going to be using it, you want to make it valid with a 1 at P100. And then a very common one when you get your chiller, it may be in Celsius. So you're going to change P104 to Fahrenheit in most cases. Our Canadians, they like the 0 for Celsius. And heat recovery function, that's not available. Should never see any errors associated with that either. And P106 through 108, these are for the V18. We're going to go ahead and set those up on paper here when we do the V18 commissioning. And let's see. Okay, P109. This is where you can lower your set point for cooling lower than the factory default. The factory default comes out with the lowest setting being 10C. If you change the setting to a 1, P109 to a 1, you can lower that to 5C. And these are return temperatures. So that 5C, as I keep saying, could go down to 0 rather quickly. And this is why we put in the statement, must use glycol to prevent freezing the system. Okay, and here's where we have a missing page. It's a very short page, but it's in the online manual. What's missing is P111 or P111. That's going to be DIN 6 and DIN 7. You're going to enable it or disable it. And that would be to work with CH and COM. The next one that's missing is P112. That's the auto switchover function. If you want to make that work, we have a write-up in the manual on the auto switchover. And I'm not sure if it's in this class. I think I added it towards the back of it. But if you guys have questions about that, you can email those in if you don't see it in this class. Okay, so here's the P parameters. On the CX35 and CX50-2, to get to the C parameters, we're going to hit the status button. And then when we get the status button, we're going to see in our next handout for the screens, we're going to see a little button in the top right corner that you're going to touch, and that'll bring you directly to the C parameter numbers. So just want to point out some of these. that are very important to you when troubleshooting your systems. The first 5 of them are going to be critical to you. There's the out pipe. That's your coil temperature outside. You're going to be looking at that if you're trying to configure your defrosts from anything outside of the standard default settings. Compressor discharge temperature. That's going to tell you a lot about Freon issues more than anything else. It's going to be high pressure along with high temperature. So we don't have a pressure gauge on the Freon side, but we do have a discharge temperature sensor. We also have a suction temperature at 0.3. Ambient temperature, that's the sensor that's on the back of the coil outdoors. It's usually taped to the grill or tie wrapped to the grill. That gives you your outdoor ambient temperature. Plate heat exchanger temperature on the inlet side. That's very useful, especially if you're having Freon issues or low capacity. That's a place to look. AC outlet water temperature, another good one. It's the same number as on the HMI desktop. Also, the outlet, the inlet temperature is not listed here in the C parameters for whatever reason, but it is on the front display on the main page. Solar, it comes with a solar sensor if you want to use a solar application. And the rest of these, C13 is your water flow in liters per minute. Again, that's going to be on the front desktop. And your different modes telling you what's on, what's off. All this is from the desktop. And then your high pressure switch, your low pressure switch, these are on the Freon circuit. So it will tell you if your Freon pressure is above 600 PSI. It'll also tell you if you're lower than, I think it's 40 PSI. I have those specs listed in the parts area, so we'll be able to look at that. But yeah, these indicators will come on. The C22 is a P1, C23 is a P2. There's a second high pressure switch, which we sometimes refer to as the mid-level switch, mid-pressure. That's used for diagnostics. It's going to tell us when and how much the compressor is going to shift gears. C25 not used. C27 is very valuable. This is the actual frequency of the compressor running. It's always good if you're troubleshooting problems, it's good to look there. Let me get some of these. The outdoor fan motor. This is going to have an on or an off, pretty straightforward. Your C4 water pump, same thing there, on or off. C6, on or off. Okay, your compressor model number. This is the board, switch number 1. We have a page on the switch settings that we looked at. There's another page showing what the switch settings are for each board, CX35 and CX50-2. It's going to tell you the number right here. C38 is going to equal X for this model and Y for this model. It's all going to be listed on the coming pages. Expansion valves. They're showing 2 of them here. Really, we only have expansion valve number 2. And you should see a value there when the compressor is running. Also good for troubleshooting. Okay, C44. This should always come from the factory set to a 1 EC fan. If it's a CX35, you're only going to see status at C45. If it's a 50, you'll see them both because it has 2 fans. All right, and C47 water type, water pump type, it's always EC. C48 is the pump speed of that first C4 pump and the only C4 pump. It's going to be 1 through 10. That's telling you how fast the pump is running. 10 being full speed, 1 being slowest speed. 0 there is going to be for it just being in standby. Shut off, in other words, put the power on using the shutdown button. Inductor current value, you can see the current listed here in amps of the chiller. I think it's pretty good for if you're logging this data. You can kind of keep an eye on it, especially if you're off grid and you want to make sure that you're getting the most out of your electricity bill. That's a good thing to log. What else do we have? The input AC voltage. This isn't always necessarily what your meter says. It's what the system sees at the IPM. So if you don't have a voltmeter with you, that'll do. Same thing with the input AC current value. If you exceed C56, the current value of 50 amps, you'll see a F5 error show up. That wouldn't be a good thing. That's an IPM problem.
Say, Mark, the voltages, let's say, or the amps, what endangers the IPM control that's on the top of the Chiltrix area that modulates the fan and so on? What do we have to keep the voltages in and so on?
You're asking about the range of voltage?
Yes.
Yeah, that's it's going to be 208 to 240, anywhere in that range.
I mean, is there a range where it could damage the IPM control?
It's going to be on our specification sheet, but there is an error code that will show you bus voltage too high, bus voltage too low. You could see those when you're getting power surges. So it does kind of give you an error when it's out of that range. But I wouldn't ask anybody to measure bus voltage. It's just it'll give you an error if it's out of spec. And that's also it. When it logs that error, it's time to start looking at your power conditions from the grid. A good indication of dirty power. And we're going to have that whole section coming up on MOVs and surge protection.
Okay.
Okay, so the rest of this stuff, e-heater, anytime you see e-heater, that's V18. And here's the status of DIN 6 and 7. You can come to this status screen and see whether, I mean, your jumper may be in place, but maybe it's loose. This will tell you for sure what the chiller sees. Now, going into error codes, I put a couple notes in here on the side next to the actual error number. So we can read through some of these. Compressor discharge, you're going to see that at C01. Outdoor air temperature sensor, that's going to be C02. Coil, C00. All these are listed here for a reason. If you get this error, I expect you to go to the C parameters to this particular one that corresponds with your error and see what that temperature is. See if it's a real error. See if it's a broken sensor. These sensors are 10K sensors on these systems. So at a certain temperature, I believe it's 76 degrees, you should see 10K if you're measuring it with an ohm meter. But anyway, if these are out of whack, you'll see some really high, crazy numbers on the status. And then high coil temp protection, I put in fan. Is your fan running? Why is the coil getting so hot? You got leaves blowing on it. You know, there's a lot of things that could cause this, but one of them I found is to be a defective fan. On the CX35, you'll get this right away. On the 50-2, you may have one fan turning on and off. This E6 could come and go. the first thing I'm going to say is go check those fans, make sure they're both running. And you can see the speeds in the C parameters because they do have feedback from these fans. Okay, E8, return temperature on the desktop for the AC inlet temperature sensor error. You'll see that right at the desktop, whether it's out of whack or not. Same thing with the outlet, but there is a C parameter for the outlet too. Domestic hot water temperature sensor, you'll see that on the desktop. What if your tank is showing -40, then you got a bad sensor. It's usually open. Same thing for indoor ambient sensor, which we don't use, but it could cause a problem if it shorts out. Water temperature, yeah, those aren't used. Discharge probe error, that's your compressor discharge. I don't know why they call it a probe error, but it's your discharge sensor. Compressor overheat protection, P3, that could be very low on Freon to cause that. It's rare, but it could happen. The P5 error, that's something that you'll probably see at commissioning, or if your water flow sensor is on its way out, or if your pump is on its way out, or if your Y strainer is blocked. So P5 can mean just really one thing, that there's a problem with the flow. And we're going to talk about the P5 when we get to the troubleshooting section. P9, communication error, that's going to be your HMI not being able to talk or get data from the main logic board for whatever reason. I would point straight to the Modbus A and B wires. Something may have eaten through your cable. One of them may be come off at the chiller from vibration. Who knows? But I would look for the Modbus A and B wires for that particular problem. Water source antifreeze, these boards are used in geothermal systems, so these do not apply to us. Control panel parameters are not initialized. That doesn't make sense to me, so I asked the factory, and they told me it was an EEPROM error on your main logic board. We may be able to fix that with a programmer. If that doesn't work, we're going to replace the board. Haven't seen that yet. P12 and P12, this one's not used. I don't know why it's still in there, but that should be deleted. P13, this is most likely your IPM was blown up, and a lot of it is caused by dirty power with the P13s. We've looked at some IPMs that had P13s in the past, and it's just unbelievable damage to the chips. They literally blow right off the board. Nothing left but a couple of metal legs. Okay, and here's the last one I want to talk about that you may see in the field. This is not an IPM problem. Inlet and outlet water temperature difference is too big. That is a flow issue, and this will point me right to the Y strainer or a failing pump. And then you could also have the guy that leaves the ball valve A closed when he's doing his flush and fill. He's got it partially closed. We've seen it all, or maybe not. Voltage protection F1, that's, again, that most likely is something has shorted out on the IPM, and there's usually a reason for that. We'll look at other errors. That error doesn't usually come up by itself. Some of these other errors, IPM fault F2, that's more of a fatal error. It's going to be an IPM replacement. And if any of you guys are wondering what the IPM is, if you're new to these systems, it's an intelligent power module. It sits on top of the system, both 35 and 50-2. It's the only horizontal board in the system. And then compressor drive errors. These are something we'll do case to case. We'll measure the ohms between the U, V, and W on the compressor through the cable, not directly at the compressor. If we see a problem with it, like more than a couple ohms, then we'll measure it at the compressor. And if it checks at the compressor, you got a burnt cable. IPM overcurrent and overheat, these are usually hand in hand. The overcurrent is now merged into the overheat. If you overcurrent, you're going to overheat. This can be checked by looking at the heat fins under the IPM. Each IPM is going to have a full set of heat dissipating fins. Those fins are below the IPM, and they are in a plenum that gets air pushed through it through the fan system. So it's going to be pushing air from the left to the right. And if you have Mr. Mouse that ends up in your chiller somehow, and he wants to build a nest, that's going to block your airflow. And it's the first place I would look if I'm getting overheating problems. PFC fault, that's another fatal error. DC bus voltage, we had talked about over voltage, under voltage. That's usually power issues. A lot of times you could see those in the history. If you do, you want to definitely check your surge protection devices or add them if you don't have them. All right, and then AC input over or under voltage F10, that's what John was asking about earlier. It'll actually tell you if it's out of range. Temperature sensor fault. This isn't something you can fix. It's built into the IPM. There's a little sensor on it. And if it faults out, it's going to tell you that it can't regulate the temperature, so it wants to be changed. So you're going to change the whole IPM. DSP and mainboard communication fault, that's not applicable to this system. And EC fan 1 and fan 2 fault for the 35, it's going to be fan 1. For the 50, it could be fan 1 or fan 2 fault. And then at the bottom, we have my favorite AC system antifreeze twice. That's if you ignored the first one, first warning. It's basically another warning, and it's rare that you see that, because the first time you see it, you'll change that parameter from I guess a 5 to a 0 after you've verified your glycol percentage. So I think that's it with error codes. This is a bad page. I need to just delete that. Let's you guys can read through dynamic outdoor reset control. Not many people use it. If you're interested in something like this, you can email us. Just be sure to read through this. You might be able to set it up yourself. I haven't really run into it or had a use for it at all with all the new controllers coming out that'll do this for you. Let's see. Again, outdoor reset control. Same thing applies there. There are parameters to set up. You actually set up an AU temperature curve, and then you're going to tell it in the mode section that you're going to be using weather compensation curves. So again, not used that often, but if you feel that your customer is going to benefit from this, just send us an email and we'll discuss it and figure out the best setup for you. Here's the automatic switchover that I mentioned earlier. The parameters are the last ones, P112, to set this up. And this is based on outdoor temperature. So it's just the opposite of using CH and COM. CH and COM switch the chiller from heating to cooling by indoor temperature. This one uses the sensor on the outdoor coil on the back of the chiller to detect the ambient temperature. And then it has a built-in deadband, which means nothing changes of 7.2 degrees Fahrenheit. So it's not going to switch back and forth just with a couple of degrees. So if you guys have any questions about this, feel free to ask. Here's your parameters that you're going to be setting.
FYI, I've got a CX35 at my house, and I do use the CHCOM with remote activation, but I can tell you that there is a deadband in this scenario, so you don't go from 110 degrees or whatever down to 45 degrees. There's, generally speaking, there are plenty of time for the unit to actually disperse its energy. So it's usually around 70 degrees or so until it knows which way to go. And so it's not a lot this really hard heating to cooling going on, wasting of energy.
Right. Yeah. Your outdoor temperatures are going to swing a lot more than they will indoors. So you're right. I would prefer the CH and COM over this. It all depends on where you live too. In our area, we don't get those extremes where the morning it could be freezing and in the afternoon it could be 65, 70. Mainly that's like New England weather at certain times of the year. But yeah, I would prefer the indoor control. So let's talk about commissioning. This form is going to be changed a little bit. We're going to ask a few more questions. It's going to be something that I want you guys to print out and record those settings that we had discussed, mainly the initial flow. With the system being installed the first time, as soon as that pump comes on, you want to record that maximum flow. We'll go to the C parameter, C48. We'll make sure that that's a 10, and then we'll go back to the desktop and record the GPM. If any problems come up with flow issues, that's going to be our baseline for troubleshooting, that number. So it'd be good to keep it with the controller somewhere.
Is that C48 at 10 gallons per minute for the CX35 or the CX50?
Right, they're the same. All the C parameters and P parameters are identical, which makes it easy. So it'll be 48 on both. It makes it easier on us too, because the CX34-3s are still out there. And there's plenty of them. So, we'll be taking calls on those, and those are the same parameters and P and C as the CX35 and the 50-2. So it makes it a little bit easier. The ones that are different are going to be the CX34-4 and the 50-1. So it's important to know what you're working on in case you have mixed systems out there, like I do here. Okay, so with commissioning, I'm not going to read through this list. I'm going to just tell you how I do it. I'm going to first ask you if you have glycol in the system. The next thing I'm going to ask you is, do you have domestic hot water? The third thing I'm going to ask you is, do you have a V18 or a backup that we're going to be commissioning? And the fourth thing will be, do you have an element in your domestic hot water tank that's going to be controlled by E1, or in other words, the chiller? So those are good things to know up front. And so we're going to start with heating mode only. We're not going to do heating and domestic hot water. We're going to go into the mode and we're going to change it to heating only. If you have, you're going to probably have a buffer tank with a floor loop. So I'm not going to commission the floor loop or anything on the load side of that buffer tank. That's going to be after the chiller commissioning. You guys can do that on your own. We're not familiar with your controls, so getting back to the commissioning between the chiller and the buffer tank, it's going to be heating mode to start with. We're going to set a set target temperature, and don't forget return water. It's going to be 110. You're going to see temperatures approaching 118 for the supply temperature. So that's a good number to start with to give it the shakedown for commissioning. You could always change it lower after we're done with commissioning. We just want to see if there's any problems that are going to come up with normal usage. Okay, so I'm going to have you start the compressor. We're going to make sure that the pump comes on, the fan comes on, and the compressor comes on. We're going to be looking at the controller, so you'll be inside with the controller, the HMI. And if everything looks good, I'm going to tell you to keep an eye on the error light that's up in the top right corner. If that error comes on, you need to call the person that you're commissioning with and tell them what error you have. And the other phone call you would make is if the system met your set point and the compressor turned off. At this point, we want you to call us, whoever is doing the commissioning with you, and we'll move to the next step. The next step is going to be domestic hot water. So you can either add domestic hot water to it, or what I like to do is just run domestic hot water mode by itself, because we want to check out the G2 valve and make sure that it's functioning. And we could do that just by raising or lowering the set point. There's not much to it. It makes it simple. So we'll commission that. And once that it either looks like it's going to meet set point, if the tank is 55 degrees and your set point for normal usage is going to be 118, the first time you're heating this tank, it's not like a conventional tank where it's going to do it within an hour. This is going to take a little bit. So I'm not going to ask you to wait there until it's 120. I'm going to pick a number, like, depending on your starting temperature, I want to see a 20-degree rise from your starting temperature. So at that 20-degree rise, watching the controller, you're going to call me and tell me everything's going well. I don't have any errors. I'm going to tell you, lower the set point. Let's see the valve close, and then we'll activate heating to make sure that it closed properly. That would be it for the heating cycle. Next, what we do is the cooling cycle. We'd go ahead and test the cooling without loads. All these tests are going to be with your loads turned off. We want to see the chiller functional without a load, because the second part, after we're done with commissioning, you're going to have your loads on, and you're going to call us if there's any issues, which is very rare. If the chiller works during its normal commissioning, it's going to perform, if designed properly, it's going to perform as advertised. So the last thing, the next thing we would do is we would move to your V18 for commissioning. This we're going to do as a part of this class, and we're going to see and understand the parameters that are involved and how to fake out the chiller when you're doing a commissioning and it's not cold enough for the V18 to come on. So the last thing we would do is, if you have an E1 setup situation with an element in the tank controlled by a contactor and the chiller controlling the contactor, we would go ahead and test that. And we would, that's a really easy test where we would just raise the set point of the tank really high. The chiller would look at it and it would say, well, the ambient temperatures in range, but that chiller, that set point on the chiller is just way too high for me to heat that water up quickly. So I'm going to use E1 instead. E1 is also used for Legionella, and I believe it's 120 degrees. It'll shift over to the element only and bring that tank up to 140 degrees, which is the Legionella range. So it'll be done by element only after 120 degrees. And I want to point out that some of this stuff may change And as it does with software revisions, we're going to be updating our manuals accordingly. So right now, I don't have all the features that were changed with the latest software, but we will have those as soon as they come out and they're approved to be released.
FYI, what I understand is if you want to kill all the bugs, it's about an hour at 140. And if you did it every other week, that would be sufficient. Um,
Yeah. Okay. Well, it's all about local code. California has a stricter code than just about any state out there, with the exception of New York. Um, yeah, if they're telling you, they may raise that temperature up, John. I don't know what their standards are, but all that can be set up and changed in the parameters. Me here, if I was just concerned about Legionella, I would use 140. I would use it 1 hour of 140, and I would do that once a week. So yeah, you want to check your local codes for those settings. Okay, so what we're going to do, I'm going to talk a little bit about your percentage of glycol. A lot of guys are in the field trying to calculate this by mixing gallons and getting the right percentage. That's a good way. That's a good start. But if you guys are doing this for a living, I would get a refractometer. You can get one for about $70, but it's really easy to use. You take a drop of your solution, your mixture, you put it on the screen, you hold it up to the light, and it shows you a scale of where you are with that percentage of glycol. And that allows you to just dump some concentrated into your pump bucket and just keep pumping and keep testing until you get that right percentage. And you can really get it perfect with a refractometer. And you can get those on Amazon.com. It's going to be for propylene glycol. Some guys use the little bubble one that my dad used to use with his car with ethylene. But they do sell one of those bubble ones for propylene also. They're very inexpensive, under $20. So you can go either way. Just try, don't skimp on the glycol because you will pay for it. If that brazed plate heat exchanger cracks and it's not a manufacturer's default, it's not under warranty. And when they crack, they mix water and glycol with your Freon and Freon oil. It goes right through the compressor. It goes right through the coil, the reversing valve, the EEV, everything. Everything has to be replaced at that point, which to me makes your chiller worthless. So be very cautious with glycol and the area you live in. A lot of your low temperatures you can find in the history on the Weather Channel. They have a tab there that you might have to dig for, but it shows the history in your area of the lowest temperature in the last 10 years. That's the one you want to go with.
I think in our area, it's at least in outside of the foothills and the Tahoe Arena area, our danger is in the cooling mode. So if the flow would turn off while the compressor's working on the cooling mode, then we could have a freeze damage to the exchanger.
Right. Very good point. And if I have any Hawaiian friends out there, that applies to you too. And my Miami guys, they don't like to use glycol. They don't think it's going to be a problem. So anyway, I'm done stressing glycol. If you guys have any questions about glycol specs, or you run into a brand that you want to use that you may be unfamiliar with it, you can run it by us. I've had guys go to Walmart and get the propylene glycol that's 50-50 mixed for RVs in a pinch and work that into their systems. So just the golden rule is have enough and propylene only. Okay, so what we're going to do is we're going to move into the parts section. And what I have here is the breakdown of the CX35. And again, I wanted to point out that if you want a different view of this, you can either email me or John. We have the program that allows us to manipulate this drawing, remove covers, spin it around, turn it upside down, whatever way you want. You know, if you have a question about refrigeration parts on the back side that you can't see here. So anyway, we're going to go into the part numbers, and these are for the 35 only. Most of these part numbers are going to cross over to the 50, with the exception, of course, as like the covers, the IPM is different. The braze plate heater is just different. The EEV is different. And I think that's about it. But we're going to have a parts guide for the 50. If it's not behind this page, I'm going to go ahead and send it out separately. So when you guys are looking at these parts, it's mainly going to be for inventory purposes, telling you the exact part numbers that you're going to use to order from us or restock. It's not really something for the guys in the field to tell us or be responsible for part numbers. I think the descriptions here, if you look at the previous page and identify the part, like for example, the expansion tank right here, and then go down and verify, yeah, that is the expansion tank. That's what has a hole in it or is leaking or something. That's what I need. Then you don't need to tell us the part number. We know that you have an expansion tank, and you're not telling us about a liquid storage tank or gas separator tank. They could all look the same in there if you're new to this. Okay, so that's the end of this manual. John, what do you say we take another 5-minute breaks or 10?
Probably at 10. I think people need to stretch here a little bit. So say 11:16. Come back.
That'll work for me.
All right.
Okay.
Thank you, Mark. Please continue.
Okay, what we're going to do is look at the CX50 parts. Again, we have the 3D model that we can do just about anything with if you want to see parts that aren't shown here. But I think we have them all numbered, but it's available if you feel you need it. And the part numbers, they're all listed here. I'm not going to go through them. I already told you which ones were different. You can compare the two sheets when you get the printout and just mark them off as CX50, CX35, the different parts. So with that said, let's move into the CX screens that I had been talking about. Let me pull those up here. Okay, I put this together just because there's a lot of maneuvering through these screens when we're on the phone. This is a good handout to have if you're new to these systems. Over time, you'll know this like the back of your hand, but for now, it's good to have in case you get lost or stumped and you haven't called us yet and you're in the middle of nowhere. It's good to have this. So we'll start off with the desktop. And in this one, we have the error light on. So that tells you right away that you're going to need to maneuver through the screens. And the first one we're going to do is we're going to hit the status page. We're going to look at that. As I mentioned, on these two systems, the 50-2 and the 35, the first screen you're going to see in status is going to be the schematic of the system. And you can see the parts and pieces that are lit in yellow, those are active. So I'm just going to run through some of them that we're going to look at. The C4 is your water pump. It's very small. I don't know why, but it should be large because it plays a big part. The number 1 is it right smack in the center of the screen. That's your compressor. And then I can't read. I think it's 3 is the fan. Of course, it looks like a fan, so you can't mistake that. The other one's going to be V4, which is your reversing valve. And I can't really make out. It's going to be one of these two. It's V4 is in Victor. That's your reversing valve. So when your system's coming up, you'll see these active. Plus, if you're doing domestic hot water, once we get the software revisions straightened out with the domestic hot water and the E1 rules, you'll see G1 or G2 lit up. So right now, I think it's backwards where when it's off, your hot water, your domestic hot water is active. When we change it and make that permanent software change, it's only going to be active when G1 or G2, which are the same valve. It's a domestic hot water valve. These are just two different states for it. They're logic states, G1 and G2. So when this is lit, that means that your domestic hot water valve has turned to the domestic hot water tank. And when it goes out, that means that it's on its way or all the way back to the buffer tank position, figure 2. So I don't want to bore you with any of those now, but there are E1 and E2 elements down here. E1 being your domestic hot water element, backup element. E2 is going to be, in most cases, your V18. Okay, so to get to your C parameters, on this page, up in the top corner, you'll see where it says press here. That's just a little button. Some of you guys may remember the details button on the CX34-3. Well, this is the same thing. You touch that little button and it gives us C00, which is the first C parameter. Okay, and then you use the arrow keys to scroll through those. And these, I want to mention that they're only going to be available in Celsius because they're parameters. The reason the desktop can be converted to Fahrenheit is because they wrote a simple script program that converts it from Celsius to Fahrenheit only for the desktop. So our engineers, they understand C very well. So that's all that's available. And so if we want to go to the settings page, again, we're going to touch the settings button from the desktop right here. And it's going to give us the first settings page. Depending on what we want to do, we have version at the bottom. We have administrator, second from the bottom. And we have timer functions, which we're not going to cover in this class. Again, a lot of people use the timers for off-grid scenarios, so they can turn their systems on when the sun's out and do different things when the sun's down. I don't really follow it too much. Timer can also be used for domestic water applications when you're if you can swing it where your domestic hot water only heats up when your rates are low. This is where you'll do it with the timer. So it's all pretty straightforward. If you ever want to look at it, there it is for you. So what we normally do is we go into the administrator function. And once we get into the administrator function, well, I'm sorry, let me back up. When we go into the settings function, which is lit in white, it gives you this second screen. These are all secondary settings. They're pretty straightforward. I have them all listed right under the settings screen. You have the language. This is part of your timer. Your screen save time, you can adjust that from when it goes into screensaver, like your desktop at home. Backlight percentage is adjustable. If you ever have to calibrate your touch sensitive screen, this is the way you do it. You just basically go into the calibration screen, or they call it touch screen fixing, and you touch number 1, number 2, number 3, 4, and 5 in that order, and it calibrates to where your finger landed. So get it right the first time, and it should work for you. The other one here, factory reset. We do this after every program update. Anytime we update you, we're going to do a factory reset, and we will come back and check a few settings to make sure that if you have custom settings that you wrote down, we can go ahead and change them back to your custom settings after the factory reset. So if we go down from that, the settings page 2, we hit the timer. I'm going to show you some examples of the timer. You have timer off, timer on. You tell it what mode that timer 1 is going to be in: heating, cooling, domestic hot water. You have timer 2. I believe there's 4 timers altogether. So if you want to play around with that, it's all going to look like the same page, except the timer number is going to change, and you can change it to different modes for those time settings. And again, if you get stuck, you can give us a call, and I have a lab. I can set this up and make sure that we're doing it right. The administrator, the first time you power up your chiller, you're going to have an arrow through your administrator button, a red one. Just touch it anyway, and it's going to ask you for your user level password. And in this case, for administrator, it's going to be 2222. You're going to hit the ENT button for enter, and you'll come back around. Now your administrator button will be free and clear to press again. And that's where we're going to be into the P parameters that we can set. Okay, the last page on the settings is going to be your version. That's going to be your software version. And this password is also 2222. If you ever come to a user level that doesn't accept 2222, there are some of them that will require a 3333. And this is what your version screen is going to look like. It's good to just take a picture of it instead of trying to write it all down. Send us a picture if we ask, and it'll be a very helpful tool for understanding problems or any type of issues that come up. Okay, in the mode button, I see something that just popped up that I was hoping I erased, but these are going to be Wi-Fi enabled. I don't know who has the units with the Wi-Fi, but they're coming out of the factory with the Wi-Fi symbol. So in case any of you guys spotted that and are wondering, hey, what can I do with that? I don't think it's available yet, but it's coming soon. So here's your
is the CX. This is the next container, which will be showing up in about 3 weeks. We'll have the Wi-Fi enable, and I guess some of the earlier versions can be adapted through the software update to do it. I'll have to have that verified with John Williams. But the newest units that we have coming will have the Wi-Fi available.
Yeah, that'll be nice. A nice feature to have. We could do a lot of things remotely without being on site. So good to have. Okay, so there's your modes. Domestic hot water is not there, but I just wanted you to see that. Touch the mode button. That's where they are. And that's the end of that mode screen. Next one's going to be the error screen. You're going to touch the error button from the desktop, and you're going to see your errors here. Your current one is going to be on the top. I I don't know. I wouldn't really clear any of these errors unless you're going to reset the error like a P5. Most of these errors that come up are going to be stopping the compressor, and they will require you to power cycle the unit. Now the CX35 power cycle, we're going to do 30 seconds for that. So what that means is you hit the breaker, turn it off, you wait 30 seconds before you turn it back on. This is for all the capacitors to drain. The CX35 isn't as big as the 50, but it will not correctly load memory or any changes from P parameters that require a power cycle if you don't wait that 30 seconds. The CX50-2, it's going to be 2 minutes minimum anytime you have to power cycle. So please don't forget that. Don't cheat yourself. If it doesn't drain completely, or if you don't believe me, look at the IPM and you'll see that there's a LED on there, possibly on the main board also, that will not go out till close to 2 minutes without power. And that means that any programmer you're plugging in or any change to the memory that you made may not take effect. And it's definitely worth your time to wait. So if you guys want to keep this little handout handy, it's good for the first time until you get used to the system, save you a lot of frustration, and it'll make you look like a genius in front of your customer. So with that said, we're going to move on. And next thing we're going to look for is we're going to talk about common errors and troubleshooting. Okay, so for you guys in the field, you probably recognize this first one, P5. It's a good error because it tells us that our system is not running properly, and it's all based on flow issues. So when we get a P5, we're going to look for the obvious. We're going to look at your settings, for example, for minimum water flow before it gets a P5. On the CX35, it was a 9. On the CX50-2, it was a 14. That's liters per minute. Anything below those two numbers for each system will generate a P5. One thing about P5s is they could come and go. Okay, so if you have error in the line and it's going through the flow meter and it skips a couple spins or just hesitates for a minute, it may throw a P5 and then clear itself as the bubble continues on. Those are common also. So those are easy ones. It just means that you have to purge the system. If all fails and we can't find the P5 problem, what we're going to do is we're going to shut the flow sensor off and we're going to watch the system temperatures. That's temperature in and temperature out. Okay, so between those two, there shouldn't be more than 5 or 6 degrees in heating mode. We never do this in cooling mode. It's only heating mode. And we watch those two temperatures. If they stay within 5 or 6 degrees, and again, this is with no load, turn your fan coils off, air handler off, floor loop off, turn all that off. And we're going to watch these temperatures. If the chiller can't keep up with the buffer tank within 5 or 6 degrees, then there is a problem. And it is a pump. It's a blocked Y strainer. It could be a valve. It could be any blockage. So if that's the case, then it should be easy to fix. If it stays within 5 or 6 degrees, then you have a flow meter that is defective. We can purge the air out of it. If you have air bubbles, you may see that 5 or 6 degrees go further apart, but basically you have a bad flow meter is what it's going to boil down to. If you're in heating mode, we can leave that flow meter disabled. We did that by changing P64 to a 0. If you guys remember back in the parameters, that's to tell it what type of flow switch it's using. P64 at 0 means, hey, there's no flow meter, so don't worry about it. You won't see any flow, but your system will run in heating mode until you get a flow meter. If you're in cooling mode, you need to get one quickly. Do not run the system without a flow meter. Okay, and moving on to the pressure errors. These are Freon pressure errors, the two common ones, P1 and P2. P1 error is a high pressure on the Freon side. P2 is low pressure. We could talk about P1 problems first. They're usually water flow issues where we would watch the compressor frequency. We could watch the pump speed setting, and we can actually watch the flow meter. We're just going to toggle back and forth and record those numbers. One of those is usually going to be off, and I would say it's going to be the flow meter, not we'll see. Hopefully the flow meter is accurate and it's seeing the wrong flow at the certain compressor speed. That will cause it to overheat. You got to remember, with a water to air system, these systems have to move the heat from the heat exchanger to the load as fast as it's produced. If it doesn't and it can't keep up with it, that pressure on the Freon side is going to rise. And it's going to get to a point where it's going to be over 600 pounds or 610. I did write them down here, and give you a P1 error. And this shuts the compressor down and opens up the equalizing valve, which is like a little gateway between the high pressure side and the low pressure side, controlled by a solenoid valve. So that'll open up and the compressor will stop, and wait until that pressure is equalized. Then it'll attempt to start again when it gets down below 522. So these problems mostly fixed by correcting the flow issues. And again, you got your Y strainer out there that could be causing problems even after a few years. We've had stuff develop in tanks that breaks free, very small particles, but over time they tend to clog the filters, which is a good thing because you don't want your heat exchanger clogged. You'd rather have a cleanable, reusable filter. So if the P1 can't be fixed, we have other ways to look at this. We have data loggers that we can connect and run the system with the data logger, log in data, and then we can put it on a spreadsheet and see exactly what's going on when that error condition was met. So that's a higher level, tier 3, and we'll notify you if you need a data logger if all else fails. The other thing I want to mention about a P1, and this is just common sense, but sometimes it's overlooked. If you turn your chiller on and it comes up with a P1 automatically and nobody has messed with the Freon, then it looks like a wire came loose from the pressure sensor to the main board. We've had that happen. So you can't really get a P1 with the compressor off. Okay, if it is, it's a bad switch, which we never had a bad switch, or it's a wire that broke free or was pulled loose during installation of the pump or some other device. So moving on to P2 errors. Okay, the P2 means low Freon. A lot of the times it is. If you see a P2, cross your fingers and hope it's not low Freon, because low Freon doesn't evaporate inside a closed loop. If you have a low Freon situation after the system's been installed and running, chances are you're going to be looking for a small pinhole leak somewhere, and you could use dye, sniffers, just about anything. Make sure your sniffer is able to pick up R32, the new refrigerant. And R32 is used in both of these devices. Everybody's moving to it, so you might as well upgrade your equipment. The other possibility is if you have your gauges on and we're looking at a P2 error after a certain amount of time, maybe 5-10 minutes, we're going to look at the EEV. And EEVs, they sometimes go out. It's a little valve inside. Most of you guys know what these are and what they're used for. And if any debris or anything that comes in with the Freon gets stuck in that, it could cause problems. Or it is a coil slipped over a bulb that has a little motor in it. And that coil, you can pull that coil off and look for rust. I've seen rust in some of these, not all, but some of them. And by cleaning it, you can just eliminate a lot of these P2s that come and go. Or if it stays and it's really rusted bad, that's one thing you can look at. Another thing, make sure the EEV is plugged into the right socket, especially after you change a board and all of a sudden you get a P2 error. That could be caused by parameters at that time after changing a board, or you simply plug the EEV into the wrong port, because there are two of them. And I pointed that out in the manual itself, so you'll be able to look at that to double check. Low pressure opens at 4.35 PSI, closes at 29 pounds. 29 pounds and 30 pounds, that's still kind of low. May not trigger a P2, but if you're getting P2 errors and we can't find something that's causing it right away, a parameter or EEV actuator, we're going to put gauges on it, and we're going to see if you indeed have just low Freon with a possible leak. We do allow dye in these units. I'm not 100% sure on the R32 dye if it's different than the R34. I would imagine it'd be the same. We've also had people use the stop leak. It's a formula that was made to stop a tiny little pinhole. By as soon as it hits the air, it solidifies. So as it's going through that hole, it'll actually start blocking it under pressure. So we know it works really well. The stuff that we recommend is from a company that makes Leak Lock, and they're a chemical company, and they are online. You can look up Leak Lock and get the parent company and look at their products. One of them is going to be this leak stopper. I forget what it's called, but it does work in most situations if the leak's small enough. Okay, so moving on to IPM errors. IPMs, they're very sensitive to power. I mean, this is a power supply with a brain. And we put MOVs on them, and we're going to get to that next. And surge protection, especially if they start detecting those bus errors. A lot of times you won't be there when they're doing construction, just big construction, and switching the power from one grid to another and back and forth when there's brownouts. But they do it, and their equipment is sometimes dirty, and it's going to put these what's called transient voltage spikes on your line. These things could be 900 volts and come in very quickly. And those are the ones that put holes in circuit chips. So MOVs are installed in most surge protectors, and also sometimes manually, as we'll see in the next handout. And they self-destruct, and they'll turn black when they take a hit. So they're $1 each compared to, $400 or $500 for an IPM. So I would definitely be using those, and don't wait until you have power problems. These, again, they're $1 each, and I'm going to show you where to buy them. And you could put them in a couple different places. It's up to you. But anytime we replace an IPM, it's going to go out with MOVs on the IPM itself, in addition to whatever surge protection you have. Okay, so Where'd he
Do you have any
go?
recommendations on the surge protection type devices? Because it is, 240 volts is different than what people commonly find for like what protects their computers.
Are you asking for recommended
Yeah,
MOVs or surge protectors?
it's surge protectors.
Yeah, that's right here in the MOV and surge protection. I'm going to cover that. So, yeah, if you have any
Okay,
questions after these 2 pages, let me know.
okay.
Okay, so these are our MOVs, and I'm going to blow this up a little bit so you can see. We use 2 different types of MOVs, and they look like capacitors, ceramic capacitors, but they're not. They're metal oxide varistors. So we have one style that goes across L1 and L2. It's the V300, which is the clamp-in voltage is 300 volts. I got these really low because I don't want anything over 300 going through the system. The other ones from L1 to ground and L2 to ground are going to be the V150s. And you can see the way they're attached. This is the power block. If you don't recognize it, you can put them there. You can put them on your IPM. And that's shown right here. Yeah, this will be on the connector of the IPM itself. Let me move that over. Yeah. So again, the 150 is going to go from ACN to PE and ACL to PE. And then the 300 is going to go across ACN and ACL. Now, of course, we know PE is earth ground. And in Europe, they don't have the L1 and L2 out of phase by 90 degrees. They just have 240 across 2 wires, kind of like we handle our 120. You have a neutral and a load or a line, whatever you want to call it. It's going to have 240. Either way, when you measure it with a voltmeter, you'll see 240 across it. So that's their terms right here, but it's the same thing, L1, L2, and ground. So those are the MOVs. You can get them at a company called Mouser. And if you cut and paste this link, it'll bring you right to it. This is for the 300, and this is for the 150. I believe it'll work on the PDF itself. Okay, so here,
Mark,
go
I
ahead.
got a couple of questions come across. So we don't need a external surge protector to protect the 240 volt line.
Well, this is what we do in addition to the surge protector. The next page of this is going to show you what we prefer for a surge protector because it's easy to use. It's wired in parallel with your breaker. But there's all different types of surge protectors. That's your first line of defense, would be a whole house surge protector, especially in California where they keep monkeying with the power. You know, during the summer, their usage goes up one area, they got to get it from another. That's a lot of switching going on. So we get it here, but it's only during the winter mostly, and it's during a storm. When a line goes down, that's when we get IPMs getting taken out. And it's mostly New England. And I'm not picking on New England. I'm from New England. But we have ice storms up there that are really bad, cause a lot of damage.
Do we have ones that could be sized more toward the HVAC system like the Chiltrix only? Or do we need to get the whole house surge protector?
Well, you could do either. If you have devices in your house, computers, anything electronic, and you're having power issues, I'd go for the whole house. But our IPMs are a little bit more sensitive, and they flag errors when they see them before they actually destroy the parts. So just because your TV made it through it, it may have its own surge protection built into it, or MOVs. Ours don't. They don't have the problems in Europe as we do. They do different things with their grid than we do. So we have to add this stuff to our IPMs in some cases. So the one that I would use just for the chiller, and this can be mounted in a box outside the breaker, or DIN mounted even. They have DIN rail mounts, but this is the one that we recommend. Very simple installation. You connect L1 and L2 to your breaker, L1 and L2, and then you connect your ground to it. And then this is what it looks like on a DIN rail. And these packages pop out. These are replaceable. So if you do get damage, those take the hit, just like the MOV does. And these have MOVs in them.
Okay.
So this is the company that makes them down in Fort Pierce. Really good place to go fishing, by the way. So yeah, that's the contact. And Ryan Fitzgerald, he's a sales engineer. If you have any questions about tech specs, wiring, multiple breakers, he's the guy to go to. And he's pretty quick about answering emails. So what we're going to do next is we're going to go to the flush fill lab. Okay, this looks familiar. This is our flush fill procedure. And it's the same as we looked at earlier. It's just a little clearer drawing. I'm going to show you what one of these looks like. This is a store-bought one. I think it's by Weber. Let me take a closer look here. Or Webstone, W-E-B Stone. They make these all in one piece, and works like a champ, easy to install. There's very little air bubbles that are left in this, very tiny. But if you're using a system like this, you have your air pockets are going to be right here. This is why I say get these T's as close as you can to this middle ball valve. And don't worry about an inch or two, because when you're doing your flush and fill, after you get the most of the air out, you're going to turn this valve open and close, valve A, and just shake the system up. Those air bubbles will come out, because now this water is going to be going both directions, and then you close the valve and it goes this direction. It'll drag all that air out with it on both sides. So again, this one, you won't have to do that, but it's more convenient to buy these as one kit. I wish I had the part number to them, but if you go to their website, I'm sure they'll be there. And again, easy to use. Now, since we're talking about flushing and filling, once we get all the air out, we're going to run this pump for like 30 minutes minimum. Okay, so we want as much as possible out. And once we get all of it out, let's say the hose on the right is going to be your supply coming from your bucket. The hose on the left is going to be return going into the bucket. When you're done with your flush and fill, turn the valve off on the left and watch your pressure gauge. Have somebody outside, and when it maxes out, close the valve on the right and open the A valve. So now you have a closed loop under pressure. And then you can go outside, you can look at your pressure, and you can open the return on the left until that pressure drops. Say it goes to 60 or so. You got a really strong pump. Lower it to 30 just by opening this valve, close it, and you're done. It's simple as that. So on this next page, this is when you're setting up your loop and your system, and you're wondering, where do I put valves? How do I look at this system from a aerial view? and figure out where to put my valves. Well, I put this drawing together just for that. We could start with the green valves. Okay, the green valves is going to be, of course, on the chiller, one on each line, supply and return. And then at the buffer tank end, we're going to have a shutoff there for the supply and a shutoff for the return. Okay, you'll do this on each of them. But for now, we're just talking about one chiller. Now, these valves are obvious. If you have to do any maintenance on the chiller, a pump, a flow meter, you don't want to have to drain your buffer tank or this whole loop here. Just simply put those valves in and shut them off when you're working inside the chiller. I also mentioned a couple valves on each side of the Y strainer, which is this black device here. That's optional, but again, as long as you cut the water off at both ends, the maximum amount of glycol you'll be draining would be just between the two ball valves. So good thing to have, minimum. Next would be using valves for the flush and fill. I recommend on your load side, anytime you have a load, always have a valve in place one on each line, just to isolate your system from the buffer tank. If you have to replace this pump or something goes wrong with the flush fill kit for that side of the loop, you don't want to drain the buffer tank. You just simply shut your valves off. Also, when you're doing the flush fill from your chiller to the buffer tank, you don't want to do a flush fill on this side. You have a flush fill kit for that load side area. So you're simply going to shut these two valves off, and then you're going to do your flush fill. It'll push water to the buffer tank, only one way out, that's to come back. And do one chiller at a time. Also, domestic hot water, while we're looking at it, when you're doing the flush fill for it, just take the actuator off. Use figure 1 that we looked at earlier. Turn your valve stem with a adjustable flat wrench to the figure 1 position. Flush all your air out of your coil, and you're done with it. Comes right in your bucket. Goes back through the chiller and back into your bucket. So, John, are there any questions about any of this from the guys?
No, I've not seen any questions pop up regarding this. Oh, there were some comments from Irving providing what kind of pump to use, and use a check valve on it so it doesn't back flush back into the bucket, that sort of thing. So they've been seeing some other comments backing you up.
Yeah. Well, I don't normally use any check valves anywhere. I use manual valves to control the flow. And as far as the transfer pump goes, there's all different types of transfer pumps. The thing I want to stress about a transfer pump is when you're picking one, the minimum pump would be the equivalent of a Liberty 331. And the things to look for when selecting a pump, are you going to be doing 2-story houses, 3-story houses? Because if you are, don't forget, when you're doing the flush fill, you have an open loop. So any elevation in pipes is going to be 1 foot of elevation is going to be 1 foot of head pressure on that pump, because it's got to push that water all the way up to the 3rd floor. So that's something to consider when selecting a pump. A lot of people, it's hard to tell where you're going to be working, but if you have a lot of 1-story situations with these chillers, then you only need the Liberty. If you get taller than that, you need to look at the flow curves of your transfer pump to decide, which pump you're going to use. Very important. The circulator can be a little wimpy circulator, 1/6 of a horsepower. That's because the loop is closed when it's running. So whatever it pushes, it's pulling. Not so with a open loop.
Say there's a few more things. Let's say sometimes people get the supply and return all mixed up. Well, what is the supply and what is return? I tend to use inlet and outlet to the heat pump to clarify where things go, like the strainer. It shows here on the return, and I think someplace else it says supply, but to make it clear, it's going to the inlet of the heat pump.
Right, that's about where to put the flush fill, if I heard that right.
The flush fill, you have it on the supply on the outlet side of the heat pump, and the inlet side is the Y strainer.
Right, exactly. There's one other thing I didn't mention in this drawing. You'll see on the buffer tank, there's a TP valve up there. TP valve isn't necessary. There's one built into the chiller. TP valve is definitely necessary on a domestic hot water tank. That's not part of the glycol loop. But this TP valve that we put up there, that's just for venting. So it could be a TP valve, or it could be an air separator up there, because all your air is going to end up in the top of that tank. And if you notice the ports going in and out, there's 2 to 3 inches of air pocket above them. So you do want to vent that out. And you do that after your flush fill. And that's why when you're setting your pressure, if you're going to use the TP valve method, then you'd set it maybe 5 pounds, a little bit higher than your 30 pounds that we recommend. And that 5 will drop down to 30 as you vent that air.
Okay, so what's the pressure rating on the relief valve inside the heat pump? I thought
Believe
it
it
was
or yeah, believe it or not, it's 100 pounds.
100
It's
pounds.
7 bar. It's almost 100 pounds.
I thought it was like 50 pounds. Okay, 100 pounds.
Now it's, the TP valve over there, you're probably going to end up with one either adjustable or a 30 pound. If you can get an adjustable and put it up around 50, you shouldn't be seeing 50 pounds.
Okay, there was a comment from Sean about the TMP on a buffer tank. I know at my end, because we don't put an element in the buffer tank, there shouldn't have to be a relief valve up there. Other manufacturers put elements in their buffer tank. We simply do not. The V18B is so the question now I would say is, do we need a relief valve on the buffer tank if we use a V18? If we don't use one, I know we don't, but if we do have a V18B, do we have to have a relief valve on the buffer tank?
For me to answer that, it would be no, because the system would cover the V18. The V18 also has a thermal overload switch in it too, for an added layer of protection. So that wouldn't be required. Now,
Okay.
there is one thing that you mentioned. The buffer tanks do come with ports and doors for elements, but we call that emergency heat. And if you're going to use this tank for emergency heat, then the rules change, where you will need a TP valve according to local code if you're going to use those elements. And all that means is the chiller loop is down for some reason and you need heat. You can use those elements manually with breakers and, of course, thermostats, and run off electric backup. We don't recommend it. We call it emergency heat. But if the system's down, the V18 is not going to be working.
Yeah, we have to have a flow. If you turn off the power to the heat pump, it won't send a signal up to the V18, and we have to have a water flow.
Right. The V18 will shut off with a P5.
Okay. Does that answer people's questions regarding that? Okay.
All right. So let's see what we got coming. Okay. So we're going to look at disabling the flow meter, which is pretty quick.
Well, one more thing. what's the recommended makeup water scenario for our systems? Do we have a continuous makeup water feeder system, or like a 5 gallon Axiom type unit, or just keep it isolated, completely separate, no makeup water at all?
Okay. My answer to the makeup water is, why do you have makeup water? This is not a boiler with steam radiators that release steam. You shouldn't have any leaks in your system. And if you do, you need to fix them. If you don't want to do that and you want to put in makeup device, that's fine with us. But I normally don't recommend those. I think that you're just covering a problem that's only going to get worse. Your closed loop is a closed loop for a reason. If you have a bad crimp somewhere, you're eventually going to find out the hard way, whether it comes through a wall or so. But it's probably a good idea to fix that. If you notice you're losing pressure in a short period of time, like a few days or a week, then you have a leak that needs to be addressed, and makeup water will hide that.
Okay, I've got some concurrence. Don't use makeup water, continuous fill system.
Yeah.
Let's see another comment. Do we have to always use glycol in the Bay Area? The answer to that is a minimal amount. It's maybe not for heating only applications. What do you think? Maybe not. But if you go to cooling, probably yes.
Is that a question, John?
Yeah. Yeah, yeah. Okay, because you're the expert here. What do you think, Mark?
I'm going to leave it up to you. You're asking me about makeup water and makeup water devices, and I'm like I said, I'm just against them because they
Yeah.
tend to cover up problems.
Okay.
And the problems, if it was just a drop of water hitting the floor, that's okay with me. But if I got a fixture or something leaking behind a wall, and I can get to it before the drywall goes up, I'd like to know it, and know to start looking. These could be very small. And if you want, we can talk about leak detection at the end of this session if we have time. If you remind me, because I go through this with guys all the time looking for leaks, and sometimes they're really hard to find. Sometimes they're in the obvious places. You just have to use your imagination and something as simple as a dry paper towel. But we could talk about that at the end of the class if you want some tips.
Okay.
Okay, so what I'd like to do is go to disabling the flow meter, which is pretty simple for this system. Back in the old system, we had the CX34-3, and we'd have to put in a jumper, and we'd also have to change a parameter. That's also the case with the CX34-4 and the CX50-1. We have a jumper that needs to go in place. But with the CX50-2 and the CX35, all you do is set P64 to a 0. There's no more power cycling. You just set it to a 0, and it does not look at that flow meter. This should be a reliable way to detect a bad flow meter by what we talked about earlier, going back to the temperature in and out, making sure it's no more than 5 or 6 degrees apart in heating mode only. So it's really simple. It's just a matter of setting P64 to a 0. Makes life a lot easier than dealing with a jumper.
One more thing is it's about 12:15. How 12:11. We should take a little bit of lunch here coming up here soon, Mark.
Are you buying lunch?
All the people who are with me right now, I guess you can come over to my house.
Yeah, that's no problem. What are we talking, an hour?
Um, I think half an hour, unless people have other ideas out there, I'm willing to listen. Um, so maybe at another finish up. Irving says he wants 45 minutes. Are there other considerations out there? I got a 30-minute, 45-minute. Usually what it is, guys, is that Mark has so much information, we need to minimize our breaks. So besides, we need to recuperate. I would say a 30-minute consensus is rolling in at 30 minutes. So that's what I would suggest. If you want to conclude a certain section here, Mark, and then we'll take a 30-minute break.
Okay, let me do one more slide. It's a real quick one.
All right.
And this is going to show you the switch settings. Just to show you that it's available. What happened?
You stuck?
Yeah. Oh, it's slow. Sorry.
Okay.
I'll be right there with it. It's not dragging.
All right. Say, Rick, what do you think?
I'll tell you what.
We'll take a
We'll
break
go to
now.
lunch now. I'll figure out what I'm doing wrong.
You might have to come back out and come back in again.
I will pause the recording.
All right. Thank you, Rick. All right. We're back after lunch. We're back after lunch, and Mark, continue on. We got some other questions we'll have to deal with perhaps later on in the presentation, but let's continue with your presentation.
Okay, so what we have on the screen, I hope, is the switch settings.
Yes?
Okay. All right, just put these up here, showing the different models. You may see some of these, you may not. 34 has an 8 switch, dip switch, where the CX50-2 and 35 has 4 switches, and there's only one switch difference between the two. So I just wanted to add that into the presentation, so you'll have it. The switch settings can be observed at C38. It'll tell you which ones that the system sees. So if you have a switch that's halfway, it may not pick it up, but you can check it in the C parameters at C38. So with that said, I want to move on to software versions. Okay, let's bring it over. This is what we currently have. This is what you'll see in the VER section of the controller. It's the first one's going to be the interface. That's the HMI. And currently our latest HMI is 1.8.6. If you don't see these on your chillers, we'll eventually get them there. There are just some small changes that are made, particularly the domestic hot water setting for E1 and the rules. We'll post those when they're fully released, and that shouldn't take too long. The second one is the firmware. This really never changes that often, but it is a bin file that'll program it. The software is the same for both. It's going to be the 108.1C. So right now we're working with 108. And John, you may have 107. I'm not sure, but 108's coming out soon. So anyway, that's the versions. We'll include this in the package. And then want to look at a list of sensor part numbers. This is for all of them, all of our chillers. This is the CX34-3. You can see that they use 5K sensors for the majority of the sensors.
Hey, Mark, the screen didn't change. We're still on the dip switch.
Oh, how about that?
No.
Okay.
There is something at the bottom of the page that like it's
Did
all right.
that work?
No, you're not on at all now.
Okay, let me go back to screen change. Sorry about that.
Mark, if any of those changes in what you want us to see are in different documents, that's going to affect what we see on the screen because you're only showing one document at a time. I don't know if
Okay.
that's the case on your end, but that might be affecting what you're doing.
Okay, let me see if I can fix that really quick. Can you see a parts list?
No, not yet.
Okay. I think it got stuck.
Yep, we can see the
You see
screen that
your desktop where it says
Okay.
sensor part numbers is highlighted, and
No part numbers yet.
no
Nope.
part numbers yet.
Where did it go? I see something near the bottom too, but it's how about now?
No part numbers yet.
All right, I see. Yeah, it looks like I've lost my share screen.
Let's just go down to the bottom middle. Just move your cursor down to the bottom middle. Should say share screen. But then you have a chance. Once you hit that, then the um, the page you want to display will pop up.
Okay,
right now we're seeing your Windows directory.
okay. How about this?
Well, you have to double click on that document to bring it to open it, and then make sure in the screen sharing thing that it's selected.
Okay. See, I'm not seeing the screen share.
Maybe he needs to get rid of the screen that he has up right now.
Maybe.
Maybe you can minimize the your Outlook.
Yeah. So are you seeing anything right now?
Just your Outlook.
You're seeing my Outlook?
It's you have part numbers, sensor part numbers highlighted. That's connected to your desktop.
Okay. I don't know where it went. My screen share is gone. It says I'm sharing, but I don't see the menu.
Well, you are sharing. It's just not. It's
How,
just
what is new share?
that's what you want. So that'll let you.
There it is. It's
Yeah.
back now.
Okay, so what we are seeing is this looks like Outlook, and I can see you hovering on the part numbers thing, but you need to double click on the little PDF icon, not on the type where it says sensor part numbers. Yeah, right there. And that should open up that document. And then you need to make sure that in the screen share, that's the document that you're sharing with us. Right now, we're seeing your Outlook or whatever that Windows directory is.
Okay. Yeah, I'm missing my screen share. I had the menu up there. Let me do it one more time. There it is. And
So what we are seeing, Mark, is the program that has the application open that has the directory that starts at the top where it says common errors, and then has a whole
right.
list of things.
That's my file manager.
Okay.
But the screen share screen, I can only get it if I do new share. And then I select that screen that we're looking at, and then I come over here and open this. And I'm seeing my part numbers here.
Let's do this, Mark. Mark, let's do this. Don't do it yet. Let me finish my sentence. I want you to stop screen sharing. Then I want you to, on your end, open up that sensor part numbers PDF, then resume screen sharing.
Got you. Right now?
Yes.
Okay. Now, you want me to open it up?
Yeah, open up the document you want us to see, and then come back and share the screen.
Okay, there it is.
There you go.
There
It's
you go.
very, it's
Am
very
I on?
blown up. There you go.
You got it.
I
All right.
had it.
I'm going to mute myself, and we are still recording.
Okay. All right. So this is the part numbers for the sensors for all the different units that we sell. We can start up at the top with the CX34-3, and I'm missing part of this. Hold on. Yeah, there they are. This PDF has got a problem. But anyway, we'll straighten it out and send it out corrected. These are the part numbers for the different sensors, mainly for the CX34-3, which has a completely different motherboard than the rest of them. The difference in sensors is going to be the discharge temperature, the 5K plugs that we use when there isn't a sensor to be used. They're a different part number, but the rest of these sensors, they're 5K, and they end with 31B and 32B. The next group we have is the CX34-4 and 50-1. They are using, get to that page. They are using the 5K sensors and 10K sensors. The 5K are the plugs, and the 10K are going to be for the domestic hot water, the inlet, outlet, solar, plate heat exchanger. All these are going to be 10K. The same thing goes with the CX35 and the 50. They're all listed here by part number, and the description that was right next to the part number is down here. And you'll notice that they're all 10K, 5K plugs. The only one that's different in this whole group of parts listings is going to be the compressor discharge, which is a 50K sensor. It needs to be a lot higher in temperature. So I'll have to fix this document and add it to the group for the guys. So the next thing we want to look at is going to be the HMI update. Hey, John, can you see that?
Yes.
Okay, very good. Okay, so this is this is a programming document for the HMI. Occasionally, we will have to upgrade the software on it as the board software is updated. And if you ever look at the back where the terminal plug is, all these are going to be labeled ground, the Modbus B, Modbus A, and the 12 to 24 volt signal. And to program these, it's suggested that we disconnect the Modbus A and B wires from the back of this terminal. Actually, it's on the plug itself. I found that it's not absolutely necessary, but I'm gonna explain it the way the factory engineers explained it to me. So we're gonna take these two cables off, and we're just gonna have power and ground going to the HMI. So we're gonna do this with the power off. We're gonna isolate the A and B cables. We're gonna tape them so they don't touch anything. Then we're gonna turn the breaker back on to the chiller, and that's gonna allow the HMI to get its power. If we haven't done this already, we're gonna download the software. It's software that can only be downloaded from the chiltrix.com/software-6 site. So once you go there, you'll see that highlighted. Just download it. It's a zip file, so you will have to extract it and just put it on your desktop in a place where you can keep track of all the files that we're going to be using. So the first thing we're going to do is we're going to run the application, and it's going to be called vcredit_x86. These are C++ libraries that we're going to need to run the program and make it successful. So the main program we're going to use is going to be the load tool. We're going to highlight that, open that folder. We're going to pick load tool. And what that's going to do is put an icon on the desktop. A lot of Windows programs will have the built-in firewall and virus protection. And if you see this screen, there is a way to get around it. You just click more info, and that allows you to click run anyway.
Say, Mark, the HMI setup and so on is a little bit more complicated than many of my customers are able to do. I mean, there may be 2 or 3 out of this bunch who could probably do it. So by and large, what we'll probably do is have me in my office, upgrade the HMI and get it off to you. We might have a few extras here so that we can just get it out the door. And because the process is it does take some time to get everything set up, and then not so much at the unit, but it's mostly just getting the software loaded into your PC. But so I'll make myself available to do this and like exchange the HMIs when necessary.
Sure. Well, there is something I haven't mentioned yet, that this is the original way. We were using that male to male USB cable, but since then we've come up with a flash drive that we're going to be using. Not a flash drive, an SD card, and you'll have one of those. And anytime there's a application upgrade, we'll just email you the file. You're going to put it on that card, insert it into the HMI, and it programs it on the fly.
Oh my goodness, that's better than the last time I did this.
Yeah, this is more of a nightmare. I just wanted to introduce some of the guys maybe PC savvy and be able to do this in the field, but it's very tricky. Installing the driver is probably the most difficult driver I've ever dealt with. It doesn't always work.
So if you can just supply a thumb drive and then stick it into the HMI, that would go a long ways to making this simple.
That is what they're doing, and I know it's available right now. It's just you have to, on your end, pick up the SD card. It's a micro SD card, so I'll get more information on that. So I guess maybe we should probably just skip the HMI manual program, since you'll be doing it in the office or with the SD.
I think it's good for them to know that this stuff in the background exists, but I don't want to burn their brain cells on this. We have other things we can talk about.
Right. Okay. All right. Good point. Let me get rid of this and we'll move over to the one button, which is just as simple. Let me bring that up. Okay, are we looking at the programming, the CX35 and CX50-2?
Yes.
Good. Okay, we've made this really simple. This is for programming the main logic board. You're going to need this programmer, which will be in Oakland, the Oakland office, and you're going to need a laptop just for power. So what you're going to do is you're going to shut the chiller down with the shutdown button, and then you're going to turn off the breaker. You're going to wait 2 minutes for that unit to power down if it's a 50, and 30 seconds minimum if it's a 35. So we're going to plug the programmer into the USB port on your laptop, and it's just for power. And then we're going to plug the other end of the cable on the one button programmer into the board. And this picture is a little bit hard to see. Let me see if I can blow it up. Right, it's going to go right in this first connector. It's the only one that it should fit. So once that's connected, you'll see the blue light come on. That's to show that it's power. That socket number is going to be P14. It's a little bit too hard and too small to see in this picture, but you will see it on the board. So once you get your blue light on, that means you have power and then the connection's good. You're going to press the little button that's mounted inside this little plastic case. It's a little cutout. You're going to press that little button and it's going to start flashing and light up orange and red. At that point, the programmer light will turn blue, and then you can unplug it at the laptop where the power source is. It's a lot easier. And then this board having no power, it'll be very safe to unplug this cable. So you're pretty much finished. Now what you want to do is initialize the board, the logic board. And that's simple. We'll just turn the power on, and we're going to go to the settings menu, and then we're going to pick factory reset down at the lower right of that second menu. It may beep, it may not, but just touching it, if you're unsure, touch it twice, and then it loads the factory parameters back, and then you can turn the breaker off for 2 minutes and then back on to reload everything that you just reset. It's as simple as that. And what I would do after any time you do a program update, I would go back and recheck my flow parameters. Everything to do with a flow, you want to make sure that they're going to be the way you originally set the system up. Also, if you have changed any defrosting settings, you might want to go back and review those. You should have any changes should be logged. And at this time, you would go back through the P parameters and reset the ones that were customized for your system, if there are any. And then, of course, you have to do the power cycle one more time to get it loaded back into memory. So that's all there is to programming this. The programmers that we send out anytime there's a new revision, we're going to send it out loaded into the new programmer. So you'll receive this little programming board and the 2 associated cables with it. When we have the Wi-Fi versions, I would expect that we'll be doing this remotely, and you won't need any cables or a laptop. So it's all coming quickly. It's just not ready for prime time right this moment. It's going to be soon, and it's going to be a big help. Okay, with that said, let's see what's left here. Okay, so now what we want to do is we talked about the V18. The V18 is pretty popular over here on this side of the country. I'm not sure what you guys are doing with it, but it's a good practice to learn how to commission one, because most of your installs will be in fair weather, and it won't be appropriate for it to just turn on. You have to do some tricks to make it work. So I'm going to go ahead and pull that up. Okay, so we have V18B set up and testing, John?
Yes.
Okay, good. Okay, so what we want to do is, before we test this thing, this is a new install or a new V18 install, we want to verify the Modbus connections on the P432 main logic board. There's 2 wires that are going to go from the logic board in PWM2 that's going to go to the SSR. These are polarity sensitive. So in the diagram shown, I have red as the positive, and that red cable is going to come over to the SSR and land on the positive terminal, the red wire on the positive terminal of the SSR, black on the negative.
Mark, can we increase the size of that so we can see it better?
Sure. It's not a very good picture, but maybe that might help.
Okay.
Can you see my cursor at all?
Yes.
No, okay. All right, so is that clear that they're polarity sensitive at both devices, on the board and the SSR?
That helps.
And that's going to control the SSR current that passes through it. So now I need to get back down a little bit. Okay, so we're going to enter the parameters. As normal, we're going to hit settings, admin. We'll probably have to add our upper level password 2222, hit admin again, and we're into the P parameters. What I like to do when I'm setting one of these up is I like to set the initial parameters to factory defaults. And we'll start with P57, the activation air temperature. For the V18 to work, the temperature has to be less than P57. So if we look at P57, I'll set the default to 0. That's 32 degrees in my area. Again, you guys may be looking at 45. It all depends. It's trial and error. But the range is going to be minus 20C to plus 20C. Plus 20C, I think that's about 68 Fahrenheit. So you can see what I was talking about. You have to be below 68 to do this test. And a lot of times you're not going to be below that temperature. We're going to get back to that. That's one of the ones that we're going to have to trick. So the next one we'll move on is P56 that says we're going to set it to a 0. That means that the V18 is enabled. All right, P41 is a starting curve. That's so that the SSR doesn't just turn on like a regular relay. It's going to get pulses at a slower rate, and it's going to allow current to trickle up to the maximum. 10 is a good number that we found, and it should be at its maximum after the number of minutes set at P74. So P40 is the E2 start delay time. If the compressor is running we usually use 15 minutes. But if we set it for 15 minutes and the compressor is running and it can't keep up with its set point, say it's really cold outside, that's when the V18 will start activation after 15 minutes. This is another one we're going to change to like 5 minutes for our testing, so we don't have to wait 15 minutes. 103, that's the rated watts. So if you have the original element that comes with the V18, it's going to be 5,500 watts. So the value will be 55 because there is a conversion factor involved. P106, that's the rated element voltage. The default is going to be 240 unless you bought some strange element. It'll have a different rating on it. That's where it goes at P106. Okay, and if you have multiple V18s, P103 is going to be the value of both of those added together. Okay, and then P107, this is the transfer coefficient. This is mainly used for observation, I guess you would say, where you could look at C62, and you could see the power that it's using. We have to derate this with a coefficient when you're using glycol. The default is 500 for water, straight water, but as you add glycol, you're going to change this number to correspond with the percentage of propylene glycol. So for an example, 25%, you would use the number 473 at P107. And P108, we don't use that. It's possible future use. We're going to leave it at 0 for now. Okay, now the operation, just for review, before the V18 can activate the SSR through the chiller, the ambient temperature is measured by C02. It must be below the setting P57. So again, our highest temperature is going to be like 68. So we're going to get back to changing that with a trick. to make it think it's winter. P56 must be 0. That's to tell it it's a V18. The compressor cannot meet the load for X number of minutes. That's standard. It's going to be usually 15 minutes is what we put it at. Only when E2 is on the desktop and the SSR LED is lit, that's when the V18 will start. These are going to be indicators that we're going to be looking for when we run our commissioning test. We'll see E2 on the HMI desktop light up in red, and then we'll go over to the SSR and we'll look at the LED on the SSR, and that should be flashing and quicker until it finally turns solid. Okay, there's a couple rules about E2 starting during the defrost and stopping if the AC water temperature is greater than the target temperature. Also, you'll notice if you're looking at the HMI on the desktop, the E2 activation will also bump up the set point, the set target temperature for heating, and that'll keep the compressor on. It'll try to keep it on. But again, after 15 minutes, if the compressor can't keep up with it, that's when the E2 actually goes to full speed. All right, if a P5 error is flagged, that's water flow, of course, E2 will stop. You definitely want to stop that V18 from heating. Any error that stops the CX35 or 50 will stop the V18. So it's got some safety features built in. So now we're going to talk about actually testing the V18. So first thing you want to do is start off with page 1, make sure your parameters are set to factory. The second thing we're going to do is we're going to go to P57, and if the outdoor temperature is greater than 20 C, which is about 68, what we're going to do is we're going to put a frozen rag, frozen paper towel, anything wet in the freezer for about 10-15 minutes, and then we're going to bring it out to the chiller and go to the back of the coil where that ambient sensor is, and we're just going to wrap it around the ambient sensor. The sensor is at the end of the wire. It's about 1 inch, maybe a ½ inch. That's the only part that you have to wrap. You can go back in and look at the ambient temperature and the C parameters. You'll see it coming down pretty quick, down to say 45, 40. Anywhere under P57 will be enough. So then what we're going to do is we're going to cripple the compressor by going to P27, which is the maximum speed of the compressor, and we're going to set it to 55. We're also going to temporarily set P40 to 5 minutes instead of 15. And then we're going to turn the CX unit on in heating mode, and we're going to set the AC target temperature to the highest allowed, or anything above 120. And it'll never reach that. So that's a good number to use for testing. All right, and then we're going to enable E2 at P56, has to be a 0. We're going to wait 5 to 6 minutes as the chiller compressor is running. And then we should see the E2 indicator on the CX unit HMI. And it's at the bottom, it will turn red. And if you want to double check it for whatever reason, you can look at the status page. It'll have the E2 and the E1, E2 at the bottom of that corner of that page on the right, and one of those will be lit. The E2 should be lit in red at this time. So then you'll go over to the SSR. You'll take the cover off the SSR box. It's a metal box with a heat sink on the back. To see the LED, you have to take the cover off. What I would do if I was the installer is just drill a hole right where the LED is, so the customer who is reporting the problem can tell you over the phone whether that LED is on or not. You see, the E2 could be on the HMI, telling you it's activated the V18 and all conditions are present, and the SSR may not be on. That could be a broken wire, a loose connection, a bad SSR. So both of these indicators have to be lit. And then that'll give you the information you need to go out and repair the problem without multiple trips. So another, during commissioning, if you want to go one step further, you can hear the hissing sound from the V18 once you have the breaker on. The other way to do it is put a clamp on amp meter on either L1 or L2, which pass through the box. And you should see a good 22 amps when that SSR light is solid. Okay, and then I mentioned the C62. As an installer, you're probably not going to do these calculations, but some customers like to know what type of a draw they're getting on that V18, and they're not going to have an amp clamp. So this is what they would do to figure out the amperage being drawn. Okay, so after that, we want to go set our settings back to the original configuration that's on page 1. And P27, you want the compressor speed back to 100. P40, the delay time, you want to set that back to 15 minutes. And then, of course, set your AC target temperature back to the proper everyday heating temperature. And that's pretty much it for the V18.
Thank you.
I know there probably isn't any questions until you actually do this once in the field, but it looks a little bit, cluttered and maybe a little bit complicated, but it's really not. Once you do one, it'll make sense to you as to what you're doing, crippling the compressor, changing the delays, and putting the ice on the sensor. It all comes together when you're out in the field.
FYI, when installing the V18B, it's critical that the plumbing have the V18 in a vertical position.
Yes.
And to make sure that there's no air bubble stuck inside the element area.
Right. And let me see if I can get to the web on this.
While you're doing that, other little details on installation side, the heat pump never actually gets installed perfectly plumb. You always want to tilt it slightly toward the left rear as you're facing it. There is a drain hole back there, and you want it to slope ever so slightly toward that rear left area. And there's going to be a little, the unit is supplied with a little, it pops in clip, so you can put a hose to the back end of the heat pump, so you can direct the condensate that comes off the coil someplace away from the heat pump if you want to. Be sure to not let it become a trap, because that can also get frozen. So it needs to be very short or straight downhill.
Okay, so what I'm going to do is try to get the tank manual on the screen. It might take a minute here.
Okay. Let's see if there are other comments that came in. Another thing is the plumbing between the heat pump and to the inside of the house. We always recommend copper. And the reason is that if you use PEX and the insulation should fail, then the PEX is guaranteed to fail. And so we always try to make sure it's all copper. So if the pipe insulation gets a little bit of sunlight into it, we don't have a plumbing failure. So always use copper. I mean, you could probably use it if you went straight into the ground. Let's say some installations where you have to underground your connection between the heat pump to the inside. But once you get to the inside, then you can use PEX all you want. I just got a question come in. Anyone had E09 AC antifreeze twice? I honestly, I need help on that one, Mark. I don't know what that means.
The antifreeze twice is a second alarm that'll come on. It's related to the, let me look it up. It's related to the first alarm. Okay, yeah, it's the E14 error. Yeah, it's the E14 error. When you see that, that means that your temperature has dropped down below P59 or at P59. The default for P59 is, I believe it's 5C with these systems. You want to set it to 0. It's just a reminder that once you start dipping down into the 30s Fahrenheit, it wants to make sure you know that you have to have glycol. And again, that is not for outdoor temperature. That's going to be for your compressor driving that water temperature down into the 30s. If something were to happen, it could easily freeze. It happens that quickly. So it wants to make sure that you know when you're down in that range, you could dip down below freezing. So you better be protected from it. That's really all it is. It's not an error. It's more of an alarm.
Okay, so that's it as a alarm, then that tells the technician he's got to put some glycol in there.
That's correct.
But does it turn off the system temporarily? In that
It
alarm?
will turn the system off to get your attention. Yes.
Is it a hard lockout or is it reset itself after it warms up?
It's a hard lockout, unfortunately. Okay, 14. Okay, John, I'm going to need a couple minutes here to get this document in place so we can look at it.
Okay.
We can take a 5-minute break, maybe.
Let's see. Are there other things we can talk about? I'm going to see if I can answer some of these questions while Mark is busy. Let's see. Question.
Yeah,
Okay,
that'll
got
work.
a few chats here. Question: any recommendation for technician tools to have when you service units, refractory tester, R32 sniffer, transfer pump, pressure tester, and how to add Freon if you need it? Okay, so those really are actually more Mark questions. So we'll come back to that. Horacio. Let's see. Took care of antifreeze twice. I'll have to ask Mark also about a GFCI. Someone said they saw in the manual that we need power supply to be GFCI. Honestly, I don't think you do, but I'll have to defer to Mark on that. Let's see. I don't know if you guys saw it, but Justin Smith had a question about using a heat exchanger to separate the heat pump from a higher pressure heat pump. Say it's set operating pressure around 30 psi versus a heating system that's ancient and so cannot take higher pressures, like either copper or even steel tube Eichler systems that we find in the Bay Area. Yeah, I would definitely isolate the heat pump. I would go to the heat pump, the heat pump to the buffer tank, and then after the buffer tank, go to the radiant floor, or maybe even use an indirect. I might have to check with the engineers at Chiltrix to see if, say, a DHW40 could be used there. The DHW40 has that exchanger in there with very little pressure drop on it, and then we heat the tank side of the heat pump of the buffer tank of the DHW80 and apply that to the old Eichler system at a lower pressure, because those old Eichlers are probably operating at 5 to 10 max pressure. And then also allows us a way to protect the chiller heat pump from all the little pieces of crap that are in the old system. Let's see what else is going on here. Glycol on heating only. In our area where we rarely, with insulated pipe, it's pretty hard to get our heating systems to freeze as long as the water is running through the heat pump. I guess we can be slightly gamblers, but I think if we really want to cover our butts, we should put just a little bit of glycol in there, and then add a little bit of conditioner, so that we got the inhibitors to keep things from getting corrosive. There are probably half the installations we have out there are in the Bay Area are water onlys, by the way. But if we just want to make sure that we don't have issues, because what happens if the exchanger actually does break, it's pretty catastrophic. It's very difficult to repair, and effectively, it seems like the best thing to do is just replace the whole heat pump. So it maybe is a little bit of insurance just to put a little bit of glycol in there. Let's see, any other questions? I think I missed one. Somebody out there had a question I didn't answer. Well, go ahead, Mark.
Okay. Did you have any questions for me before I get started?
Yeah, someone saw in the manual that there's supposed to be we're supposed to power it up with a GFCI. Is that correct?
Well, the easy answer is going to be it's a code thing. It's not required here in Virginia or any of the eastern states. If that's something that your inspector has written in a code in your state or your county, maybe you can forward that to me, and I can go back to the factory and talk to them about the best way to set something like that up, what the ranges are. It's just not a common option for us at this time. They're using it on solar systems, but we're not seeing it as part of the chiller protection.
I've never seen it required for our heat pumps or heat pump chillers. It is a solar requirement. Also, I believe that most of these solar systems do supply some over voltage and amp protection. They're supposed to, at least. And but I would verify that with the solar contractor, make sure he does supply adequate protections for our equipment when they combine the PV system to the utility. It's supposed to be conditioned.
Right, yeah. So if that's required, then just shoot me an email and I'll approach the factory with it and see what they have to say about it. I just don't have the experience with those circuits for this type of chiller. So I don't want to, I'd rather them answer it. So everybody that has that question, just go ahead and send it in as an email and we'll get it answered for you.
I don't know, I think I've picked up all the questions. If I've missed something, let's see. How about
we'll come back around.
okay, good.
We don't have a lot left, so we're almost ready to finish it up. I wanted to talk about the domestic hot water and the E1 option that we have currently. Are you looking at my tank manual?
Yes.
Okay, so what we're doing is we're showing option number 1. This is an older setup from Europe. This is the way they used to do it. Basically, you have the panel going to a thermostat in the tank, and then the thermostat is controlling the element. Kind of primitive for what we're doing, because that doesn't allow our chiller to monitor, to heat the temperature before the element activates and heats it for us. So it defeats the purpose of the chiller heating your water. What we have is option number 2. And this is our preferred method. And I'm going to go right to it. We'll come back to the Legionella settings, but I'm going to go straight to the wiring diagram. I think it'll make sense to a lot of you guys. This is option number 2. So we have the CX chiller. Let me blow this up a little bit. There's our chiller. We're going to put in a 24-volt transformer inside the chiller, 240 primary, 24-volt secondary. The reason we put this in the chiller is because you'll run 24-volt, which is considered low voltage, over to a contactor, which is located hopefully near the chiller, but anyway, between the panel, I mean, not the chiller, but the domestic hot water tank. In between the panel and the tank is going to be the contactor. That's going to be high voltage, so you'll probably end up using conduit there. But for most 24-volt VAC control wires, conduit is not needed. So that's why it's in the chiller, mounted up near the IPM on that shelf. There's room under the cover. Once you take the cover off and locate the IPM, you'll see to the left of it, there's places for this transformer to just be screwed right in to the base of the IPM tray. So just use some self-tapping screws and mount it up there. The transformer, we're going to show the wiring for that in a minute, but the transformer is only going to be activated when E1 is activated on the terminal strip of the chiller. So once that's activated, your contactor will close. It'll bring 240 from the panel to the thermostat. And again, we're using a thermostat with the element as a secondary means of protection. We're going to set a high limit on that thermostat to 140, which will allow you to reach the Legionella range when the Legionella is activated. So to review, our chiller will bring the tank up to 120. At that time, the E2, E1 should come on for Legionella and take that tank from 120 to 140 and hold it there for the amount of time that you set in the parameters. I'm going to move over to the electrical side, which is pretty simple. We're going to come off our terminal strip and we're going to use E1L and L2. That gives us 240 into our transformer primary, and the secondary is going to come out 24 volts VAC, and it's going to go, and this is represents your contactor where it says from panel to element. One thing I want to recommend on these contactors, if you can get one with a manual override, that contactor will be dual purpose. Say the chiller has a problem and it's not running, it's out of service. Well, you can go over to your contactor and manually override it. It's a lever action in most cases, and override it so that your tank, you can set your domestic hot water thermostat back down to 120, and it'll maintain it there from the panel until your CX unit is back up and running. So I didn't put that in here, but there are contactors available with manual overrides that a customer could just flip the switch. Chillers down, yes, but they still have hot water. So this is called option 2, and it's in our tank manual, which is online at the Chiltrix website, along with our other manuals. Our tank manuals are specific to the CX unit model number. So be careful when you're selecting the manual that it's for your CX35 or 50-2. Currently, the 50-2 is listed on our website for manuals. The CX35 manuals aren't ready yet. They've been published internally. We have access to them, but you should be able to pick all this up in the CX50-2 manual. So are there any questions on this?
No questions.
Okay. What I'd like to do is grab a minute, and I've got I'm going to take a section or possibly the whole V18 manual. I wanted to review the installation through the manual, and I'll need another 3 or 4 minutes for that, if that's okay.
Yeah, also, I know I have a special request for the CXI fan coil installation and wiring up and all that.
Okay, I could do that next. And what we're going to do is we're going to open up the manual online, and we'll just go through the sections that pertain to the install, a normal install with parameters. And we'll talk a little bit about the board layout and how to troubleshoot it. So let me start with this V18, and we'll get that on the screen quickly here. Okay, there it is. Okay, again, we're just gonna kind of jump through this manual. I just want to point out some things that are good to know. When you're setting
Mark,
up your
going back just a little bit, I do recall that the V18B does want a GFI, GFCI.
oh, this is the device that you want on the GFI?
Well, no, Justin also mentions this, it says it in the CX34 manual. I do remember it on this particular manual because it is just a little bit higher up. You go to page, I don't know, 1 or 2. It does talk about it. I think it's on page 2. Must be page 1. There it is.
Oh, there it is. Okay. Yeah, if that's a panel breaker, it's just going to be a normal GFCI breaker.
Okay.
Yeah, that's just an added layer of protection. So the bottom line is always going to be your inspector, and what they want. So anyway, going forward here, I want to talk about this mounting shown in this diagram. This was in our lab. This will work on 80 to 90% of the installations, just using this bar type of a setup. Strapping, all this is mostly Lowe's or Home Depot stuff. One word of caution: if you have a metal framed house, do not mount this to the metal frame. It'll put out a very small vibration that only certain people can feel it and hear it. But I had one customer tell me that he attached it to his metal framed house, and it kept him awake at night when it was on. So all he did was he disconnected it and he built a wall behind it out of cinder blocks, and that was the end of that problem. Just a word of caution that when this water's heating, there may be a slight vibration. Normally you don't feel it or hear it, but if it's on metal on metal, there's a chance you might. So let me keep moving through this. Again, our basic setup with the V18 is, in all the other pictures I showed you, it looked like the V18 was mounted horizontally. Well, that's not the case with the V18s. They have to be mounted vertically, and the water flow must go from bottom to top. 2 reasons. One, it's easier to purge the air out if you're pushing the water up. No bubbles will get by. Number 2, the layout of the element, as we'll see in the next few pictures, is critical, that the bulk of the element that's freestanding is pointing up, following the water direction. If you have it the other way, it's going to cause excessive vibration, and it could possibly damage your element. So I'll get a better picture of what I'm talking about coming up here. But in the meantime, the simple installation for this, you'll have your breaker going straight to the SSR. It's going to be one leg of that breaker passing through the SSR, and the other one goes into the box, but it doesn't get broken by the SSR. So you're only breaking one leg. And I think we'll get some better pictures. This is a dual setup. Same thing, 2 SSRs, 1 cable from the chiller, providing the PWM2 plus and minus. That'll be in parallel for both of them. When one is on, the other one should be on. And just another picture of your 30 amp breaker. And there's more mention of the GFCI breaker. It should be a standard breaker that goes in the box for your panel. All right, and in this picture, you can see the basic wiring from the chiller. You're just going to have 2 low voltage wires, possibly 18 gauge stranded, and you're going to have the box. You can see a faint outline of the box itself that the SSR sits in. So this is going to be L1. It could go through the box or it could bypass the box. It's completely up to you. I would say pass it through the box and keep it in conduit, because it is going to be high voltage. L2 is being broken here. It doesn't matter if it's L1 or L2. As long as one of those legs is broken, this heater will not be on. So there is a thermal breaker that we're going to get a closer look at. There's a ground lug, and it's going to have a jumper wire inside it. And we'll see that right here. Okay, so these are your connections. This is the actual element down below where L2 is pointing. The next lug up is the other lug of the element. The element is facing up in this picture. So it's going to the top of the picture. The thermal switch has a red button in the center of it. If that pops, it'll be sticking up. In most cases, you want to, well, in all cases, you want to determine what caused that to pop. Was it the water stopping for some reason and not being detected by the flow meter, or some other issue that has come up, or possibly even a bad switch? It's rare. I don't always see these switches popping, but I did test one in boiling water, and they do work pretty effectively. They will shut off the current. So your L1 connection is going to come into the top of that, and your L2 is going to be on the bottom leg of the element. And when you're connecting the SSRs, a lot of guys, when we first put this product out, a lot of people were trying to use just the wire on the terminals of the SSR, but we discovered that that doesn't work. They tend to get hot, and sometimes they damage the SSR. So we want to use these fork type cable lugs. These are heat resistant. Mouser has them. I left you the part number there. It's definitely worth using those. If you can get those at a 90-degree angle, it'll be even easier, because that box is a 4-inch box. There's not a lot of room in it for thick cables, but that 90-degree connector will definitely help out if you can find those. Again, we're looking at the board connection. The PWM2, this picture is upside down, but we just wanted to show you a live connection in a system. Same thing we discussed earlier. It's polarity sensitive. Now, this is also an important part. This is installing the element. And one thing I want to point out is the O-ring, it must end up inside the canister, not outside the canister. So it's a little tricky to get the element in there from the end with these grommets, sealers, but it just be patient with it and maneuver it into its position, and then put the nuts on and tighten them. You want to use a torque wrench if you have them, 15 pounds for the 2 nuts on the top. If you over tighten them, you're going to damage that O-ring, and you're going to have a small leak, and it may not always show up when you commission. So be gentle with these nuts. Just get them snugged up. If you have a torque wrench, again, it's going to be 15 pounds. And when you're tightening these nuts, there is a wrench that you would use, not an adjustable wrench. There's not much room in there to maneuver a large wrench. And your wiring's going to be 20 inch-pounds for torque. And this is a blow up of the actual connection to the element. Torque settings. All right, the torque settings, just note that, you have foot-pounds and inch-pounds, 2 different torque wrenches. Okay, so When it comes time to plumbing this, you're going to have 2-inch female connections, and you'll bring it down to the size of your pipe. One thing about the chillers that we didn't really discuss is the CX35 having 1-inch connectors for the supply and return. The CX50 models have 1.25 inches. So with this V18 for the CX50, you're going to be coming down to 1.25 inch pipe, just using a bushing. And for the CX35, you're going to come down to a 1-inch pipe with bushings. Okay, and then of course, we've already discussed the parameters and the operation. Again, this manual is on our website. So if you're going to be installing one of these units, you do want to download the manual and bring it with you. And I think that's about it. And this is a view of the testing with the amp clamp. And that LED on the SSR, you can see it above the red wire where that terminal is. Let me see if I can blow this up a little bit. I believe it's right above the positive screw right there. So again, if you have a cover over this, which you're supposed to have, I would drill a hole out right over that LED so you can see it, your customer can see it without having to pull the cover off.
Okay.
And we have a section in the manual on troubleshooting. Okay, we starting off with the breaker. It's going to tell you something is wrong internally, and hopefully it detects it with this breaker and trips. The next place I would go is I would take a look at that thermal breaker to see if it's popped. You'll see the red button sticking up a little higher. You must have good flow to operate one of these. It's got to be within the range. We'll know that at commissioning. If you have a low flow issue and you're putting in a V18, we're going to have to take a look at that case by case. Okay, and this is showing you how to reset the red reset button. It's kind of a tough little button to push on. 15 to 20 pounds of pressure should do it. And if it doesn't, then just replace it. There is some white paste, thermal heat paste on the back of that sensor. If you're replacing it, try to get it off of the old one, scrape by scraping it, and just lay it out on a new one. There should be plenty, and you shouldn't really have to replace these often. It's just another layer of safety that we put in. And that's pretty much it. There is a bulletin. Yeah, this is talking about using it with the cooling mode. And what they want to do is they want you to fill the cavity, but do not cover the reset button with silicone potting material. And that's for condensation. If you're in cooling mode, you're going to have condensation if you don't protect the inside behind the door with potting material. Does that make sense to everybody?
You put some vermiculite or some other, not that, but something at high temperature that doesn't absorb or something like that inside
Right.
cavity.
If you want an example of it, I can get an example where you can look it up online, exactly what it's called. Just shoot me an email on it. I don't have it in front of me. The guys in the back would know, the guys that build these.
let's see. Anything else on the V18? Doesn't look like it. Some little things I want to touch on before Mark continues with it. Was it CXI? You can maybe able to do that next.
Yeah, we'll do the CXI. I'll go ahead and set that up. You have questions for me, or are you going to talk to the class?
I'll talk to the class.
Okay, I'll go ahead and set up. Thanks.
Okay, so one of the important little things is the covers that protect the heat pump from rain and so on. The screws have stainless steel Phillip heads, and you can take the screws out with a screw gun, but don't put them back on with a screw gun in most cases. I mean, you could probably put it on the minimum chuck, but the problem is that if you over screw it and you cross thread it, it's pretty easy to do if you have too much torque coming into to retighten the screws, putting it back together again. So either just use a regular screwdriver, Phillips screwdriver, or a screw gun on the minimum setting. Maybe Mark might have an idea on how to take the panel off to reinstall the panel where the electrical side is. I always have trouble with that side where the way the panel is. You got to go get the two side hooks in, push in on it, and then push it up, and get the upper lip underneath, and at the same time make sure that the bottom bolt that holds the Chiltrix down on that corner isn't interfering with the panel. If he's got a trick, I'd love to hear it. Some other things to look out for is it's not so much an issue when you're doing heating only or domestic hot water and heating. It's when we do chilled water, is some of the components, the electrical ones, like at the flow switch, they can, where the condensation can happen. Really good idea to add a little extra insulation around the flow switch area or anywhere else that has a little electrical. In the manifold area, if you got telestats, make sure you insulate the manifold so that condensation doesn't drip on, especially if you have it tilted upside down when you're flowing up. Do what you can to protect your telestats. Any other helpful hints from everybody else who want to chime in?
Well, I could say one thing about that question you had about this getting the side covers off when it was still on the pallet.
Oh,
was that the question?
Actually, when it's installed on the on your the service pad, I always had difficulty getting that side panel on and off.
Okay,
back on it actually.
Okay, is that when it's off the pallet or on the pallet?
When it's off the pallet and installed on a service pad.
Okay, the trick to it is you just pull out at the bottom, almost as if you're bending it towards you, and then pushing down on the handle. That's really the only way you can get past that foot. When it's on the pallet, good luck. There's pieces of wood that are in the way. Some guys like to put the pumps in while it's on the pallet, and they've called in and said, hey, I can't get this door off. Well, you have to undo the screws, and actually I use a crowbar and put it under the side of the chiller and press it down on it with my foot and push the panel down, and it'll pop off, where you can work on it when it's on the pallet. But it's recommended to do it without the pallet. Now, again, don't bend it really hard. You're just going to slightly put a bend on it, maybe a 3/4 of an inch, so it clears that foot. That's really all that's needed.
All right, so bend the panel ever so slightly, probably more than you think, so you can clear that bottom foot. That's the main thing.
Yeah.
Okay.
Okay. Do you see my CXI manual?
Yeah. Maybe lower it up a little bit, but yeah, we can see it.
Okay. All right. Great. Okay, so you guys have probably seen these in the field. They've been around since we started selling chillers. They haven't changed. Just internally, there's a board change that we made. And it's just because it has Modbus options that we went to the newer board, and it's a little bit more reliable and easier to swap out. So anyway, this is the CXI model. There is a template on our website that you can have printed if you wanted to do piping before you have your CXI units physically on site. You can bring that to the, I use Kinko's or FedEx Kinko's, and it's a 27.25" by 27.25" piece of plotter paper that they're going to use. And it comes out and it's perfect and it's cheap. It's like $5. So if you want to get ahead of the game and get your piping going, you can download that template and it'll show you where to cut the holes in the wall. And if you have any questions about it, please call before you cut. I want to point out that these CXI models, the 34, the 65, the 85, and the 120, they're all the same height. They're all the same thickness. It's the width that is different. So that's the coil size. The panels are interchangeable on each side. The right side being the electrical side, the left side being the water side. Some options you'll see tucked away inside the chiller in the box. You'll see the drain pipe. You'll see a bracket, the installation template, and where are they? The bellows and the feet and the remote. There is a package of screws, but again, if I was mounting one of these in drywall, I would like to use a toggle bolt. It's a lot more secure than one of those plastic inserts with a screw behind it, but it's strictly up to you. The little caps you see in the picture next to these screws, those are going to be in the unit. They're going to be at the side panels covering the retaining screw, so you can't see it. It looks really nice. It's under, on the right hand side, it's under the plastic door of the control panel, and you just use a small little flat blade to pop them out and access the Phillips screw underneath them. That'll allow you to lift up that panel a 1/4 of an inch and pull it out to the side. It comes right off. The bellows, the ones we're using right now are approximately 8 inches. What they're for, they're marked at both ends. One of them is going to be G3/4. That's for straight thread. These fan coils have connections to the coils that are straight thread. So these bellows will adapt that straight thread to a tapered thread, 3/4 inch. So you're going to approach your fan coil with your PEX or whatever material you're using for piping, and it's going to be at 3/4 to make this connection. All of them are the same. Just some heights, width of each of these. Some pressure drops. If you're doing your calculations, you could use the head loss in feet. You guys can read through the working principles. What I'm going to do is go straight to the ceiling mount installation, but I will stop here. When you're doing a wall mount, whether it's a floor mount or a wall mount, don't tilt the unit. Just make it level, because the condensation pond that's in each chiller under the coil, that's in there to drain condensation over to the left side where the drain is. So don't tilt it. It's not necessary. The mounting bars that come with these are going to be attached to the back of the CXI unit. They're all going to be a different size because it's the width that changes on all of these. This is a rough sketch of where the holes are for the water inlet, water outlet. Always go by what the stickers say. Sometimes they'll do different things with our coils. They'll move these around. We'll know about it in most cases, but we ask them to put stickers on the ports, labeling them water in and water out. So always go by the sticker. And there's another view of the left side of it. This is all in the manual in case you ever need it. Installing the feet, that's for a floor mount. Again, you don't have to lean this one way or another. It's already built in to drain. And you could see these are slightly different from what we just saw in the previous picture. Just really no need to update it. It's just for reference. Same with these pictures. Your ports are going to be a little bit more higher on your fan coil that you get, but it's just to illustrate how to use the bellows, 2 different ways. Closer look at the connections for the bellows. There's the G straight thread that goes to the fan coil port. The NPT tapered goes to your PEX fitting or whatever copper or brass you're using. We recommend the Blue Monster tape. Everybody says this stuff works great on the NPT side. You can put it on a straight thread, but I really don't think it does anything. The straight thread will bottom out and seal itself. Installation tips. These are the rubber washers that should come with the bellows. They should be inside. You can, this is an option, you can, if you have silicone grease, just lube it a little bit. So when you do go to tighten it, you're not going to over tighten it. It's just going to be very snug. This washer, there'll be no chance of it twisting if it has silicone on it. Just a couple tips I've heard from guys in the field. Silicone grease is different than silicone sealer. Sealer dries. Silicone grease doesn't dry. So always use the grease. And then condensation lines. There's going to be a little, what they call a ponding bucket that collects the condensation when it's on a floor mount or a wall mount. It's gravity fed through a hose out the back of the unit. That's going to be up to you what goes on behind the unit and how to drain your condensation away from the fan coil. Many different ways to do that. You can use condensation pumps behind the wall, but again, it's up to you. You will have access to the wall once you remove the side panel. Let's see. Okay, this is for us. Did you have
Looks
something?
like you've improved your instructions here. I don't remember seeing any of this before.
So all right, can you say that one more time?
Looks like you improved your installation manual. I don't remember seeing this before.
Oh yeah, I get yelled at all the time by guys in the field, and so I hurry up and do fixes. So anyway, this is a ceiling mount. It's one of the most difficult mounts out there, but again, you're gonna mount this thing level. You're not gonna tilt it one way or another. We have a way to drain it that's different from the other type of mounting options. We're going to use a piece of CPVC, 1/2 inch, and an elbow. The reason we're using the 1/2 inch is because it fits this little nipple that's on the side of the drain pan. Don't forget, this is a ceiling mount. It's not going to use the lower drain pan. The picture on the left shows the drain pan for the floor mount and wall mount all the way to the left, where on the right side of that left-hand picture, that's the actual drain pan for condensation when it's on a ceiling. So you may have to Dremel this little 1/2 inch elbow out a little bit, but that'll help you out a lot. This is where you can use silicone sealer to make it even more snug, but yet removable in case you have to service it. So the pipe that's shown in the left-hand picture is going to exit out of the bottom, no holes to cut, just cut your pipe to length. It could go behind the wall. It could go directly into a condensation pump. That's completely up to you. The whole idea of this CPVC pipe is because it's rigid, and it just happens to be a grade big enough to drain the water from the nipple on the pan out to the back. There's just enough to keep that water moving. If you had used the hose that came with it, the hose is going to sag, and water is going to back up in this pan for sure. And there's going to be some problems.
I can attest to that.
Say that again, John.
I can attest to that.
Yeah. Okay. Another thing that's not shown in this picture, in the left-hand picture where that nipple is, if you look directly above that, you'll see a change of color from the black pan to like a gray foam. Can you see that, John?
Yes, a little bit hard for folks, but yes, I can see it.
Yeah. Grab your needle nose pliers and rip a section of that at least 3 inches wide, if it's there. They may have fixed this problem, but what they did was they sealed the frame to the pan with this this material, and it blocks the flow, the natural flow of water. It makes it go around to the left of the pan, where I want it coming straight out to the nipple. So make sure there's a 3-inch minimum section of that foam. Just pull it out with your vice grips. I mean, not your vice grips, but your needle nose, to give it a clear path to the nipple.
This is only applicable on the ceiling mounted, not the wall mount.
Ceiling only, because that's the only time you'll be using this drain pan is for a ceiling mount. The pan you're going to use for wall mount is to the left. You can see it in the left-hand picture. It's that black piece of plastic. And yeah, the drain for the wall mount and floor mount is right center of that picture, right at the very top. It's a rubber like flexible piece of pipe, and it pours out of there into that drain pan on the left for the wall mount and ceiling mount.
Isn't
So
there
anyway,
a manual air vent on this unit as well? That's like in between the two plumbing connections.
yeah, if you're gonna, did you ask for an arrow on the
Air
picture?
vent. Isn't there an air vent in this unit? I thought there was a manual air vent on the unit.
For air?
Yeah.
Yeah, that, let me find that in the manual. It's not something that I normally use, especially on a ceiling mount. There's a small little bleeder valve that catches micro bubbles, and I don't like it because I don't see it here, but it uses a flat blade screwdriver. There they are, the bleed screws. They really don't do anything. Your air micro bubble collectors in the loop will take the place of those. So I wouldn't even touch them.
Okay. So let's go back to, okay, thank you. Let's go back to the mounting of the darn things. This is probably the hardest thing I've ever done in my mechanical systems, is installing a ceiling mounted CXI. So if you got a better way of doing it, let's go over that.
Okay, what part of it is the hard part? Just mounting it to the rafters?
Well, we actually had to create our own template in that case, and then measure out. And I created a flat bar with screws behind it to pick up the back end of the fan convector. So the front was the bracket like we use for the wall mount. But then for the rear, we made a bracket to when we punched out holes, put the screws into it to push the convector straight up into the holes, and at the same time slide the unit toward the wall to catch the wall bracket. So if there's some easier way to do this, that'd be great to know.
Well, to make it easier, they're going to have to do a little redesigning at the factory. We've been after them for a while, because in Europe, they don't have 16-inch on center rafters or 24-inch center rafters.
Yeah.
They use these oddball sizes. So really what you're going to have to do, if you're mounting this on a ceiling and you have access above, it's probably going to need like daughter boards to get a piece of wood over the actual holes that are in the frame of this unit. There's 4 of them.
Yeah.
Yeah, there's not much I can do about that. Yeah, you're just going to have to block it out to reach those, and then support it from overhead. If it's an attic above you, it'd be a lot easier to work. But yeah, long lag screws, that's really the only way to go.
All right, so I would suggest, is guys, you're gonna have to have your sheetrock off and put the 2x4s with a flat side down about where the unit's going to get installed, so you can screw into that through the sheetrock after the sheetrock's been reinstalled or is installed. Otherwise, it's an extremely difficult installation.
Right, and by the way, we do have cassette units that are made for mounting on the ceiling, concealed. You might want to look at our website for those. If the CXI isn't something that'll work for you, maybe the cassettes will be an easier install. They're US made.
Okay, all right.
But for US specs, I should say. All right, so yeah, I wish I could be more help with that problem, but it's a struggle, and you will eventually get pretty good at it. Every house is going to be a little bit different, so you're just going to have to be a MacGyver to get that mounted properly. And again, make sure it's level. Let's not tilt it. Okay, so a little bit of maintenance here. I wouldn't normally bring this up with contractors, but these grills do come down to allow access to the filter. Okay, and then there's a little safety switch over on the right-hand side where there's a tab on that grill, which is not shown, that has to push on that little button on the safety switch. Otherwise, you get an E0 on the display and the fan won't come on. So this is all part of an interlock system. So the unit will not operate without this grill, which has magnetic tabs to hold it in place, but also has that little tab that has to depress the little switch. Sometimes if you're a little too rough with these, you may have to adjust that switch to get the E0 to go away. A lot of guys call in and they've mounted the system and they get an E0 right off the bat. And then I find out that, yeah, they took the grills off so they wouldn't fall down because they were working with it or putting the filters in. But anyway, the E0 is all about that little switch in 90% of our E0s. Okay, so I'll move a little quicker here. It's just maintenance for the customer to do. This is the front panel that we're going to be using. I wish you could see my cursor, but the blue circle, the large one in the lower right of that panel, that's the on-off button. It does exactly what it says. The indicators for the fan and the mode are all right below the display. The 2 blue arrows are temperature up, temperature down. They're also used for setting parameter numbers, along with the button that has the M on it. That is the mode button. So we're going to go into the parameters. You guys can read how to use them. They're pretty straightforward, putting it in heating mode, cooling mode. Gives you little symbols there to go by. But what we want to do is go straight to parameter settings. This is what an installer is going to do to each unit. You're going to press and hold the M button for 10 seconds. You'll see a code come up. Normally on the newer units, you'll see it'll be a 1. And when you see that 1, it's asking you for a passcode. So you use the up and down arrow keys, or actually the up arrow key, hold it in until you see that 1 turn into a 66. When you see the 66, you press the mode button key. So the mode button key is going to be used more like a enter button than anything else once you get into the parameters. So with that said, I'm going to go to the parameter section. And this one, we're going to do the parameters for the ZLP F10 controller, which is the popular latest controller out there. And you can identify these by the serial number on the sticker on the right-hand side. It'll start with a 242 number. But again, if you press that mode button and you see a 01 or a 1, I'm sorry, or no, actually it's a 0, that's telling you it's waiting for the passcode of 66. So you put that in, you hit mode, and now you should see a 01, and that's going to be your parameter number as shown on this sheet. Okay, over on the left is the parameter number. Over on the right, under the word default, that's the parameter value. Okay, and the definition is in between them. Couple things I'm going to point out. What we do when we first install these, we're going to set all of them to defaults. Okay, the 3 and 4, these are going to change as the customer changes the set point to customize it for their application. So, but we always start with 78 for cooling, 68 for heating. And coming down this list, the automatic range is set to 78. You're going to use parameter 20, and that's just an option with 20 set to 1. Normally, we'll set that parameter 20 to 0. But before we get into the parameters any further, I want to take you through the sequence. Once we enter the 66 and we see 01, we're going to hit the mode button. That's going to show the default value of 86. If we like it and if it's correct, we're going to hit mode, and it's going to jump us back to parameter number 1. And then we use the up arrow key to go to parameter 2. And we just keep doing this sequence. When we see parameter 2, we hit the mode button. That's going to show 46. If not, we're going to make it 46. And we're going to hit the mode button there, and it's going to jump back to parameter 2. We use the up arrow key to 3, and we just do this all through this list. Okay, and all these are valid right through 9, but 10 is an option. Parameter number 10, it's going to ask you if there's a water valve. If you tell it yes, that means that there's a transformer inside with a 24-volt secondary that's going to turn on whenever there's a call for heating or cooling. Now, that can open a solenoid valve allowing water into the unit, but in most cases, it's going to turn on a pump. Sorry about that. It's going to turn on a pump to run a separate circuit to these fan coils. So it's important. If you don't have a pump and you don't have a valve or any other device that you want turned on when this fan coil is running, just leave that as a 0 and keep it off. The rest of these, the most popular one you're going to change is number 12, Fahrenheit, Celsius to Fahrenheit. Number 13, this is mandatory. You want to keep that at a 1. If you change that to 0, it could go into slave mode, which means it turns off. Okay. Local address, that's for Modbus. If you're going to be using Modbus controllers with these fan coils. 15, we don't use, don't touch it, leave it at its default. We don't ever want to lock the keypad. If you do, I'm not quite sure if you're ever going to get it unlocked if you forget your password. So I wouldn't even mess with it. 19 and 20, those the defaults are always going to be 0. I have some rules at the bottom for 19 and 20. You can read through those. They may apply to your situation. They may not. But basically, if you set it to a 0, once the room temperature is met, the fan will turn off. Okay. One thing I want to mention about the room getting to its set point, in some cases, not all, when you have a wall mount or a floor mount, depending on the room it's in and the airflow in that room, that the water running through these fan coils constantly, even if it's at a low pace, it's going to radiate cooling, and the sensor that's going to pick it up is right where those air filters are, right underneath them. So if your temperature is different on the floor where that sensor is than it is where you're standing, because people normally measure temperature with their body up around their chest to head area, where that sensor is going to be where your feet are. If that's the case and you're not getting proper airflow and it's given a false reading showing the room colder than it actually is, you can move that sensor. It's not hard to do. You just go under the fan coil. There's a tie wrap that you snip, and then you're just going to use 18 gauge wire and move it head high if you want. But most people, if you're having just a problem with the airflow from the cold water running through and the fan not being on, you could just stuff it back into the electronics cabinet where it'll be out of the flow. There's many ways to handle that sensor. If you're unsure about it, just give us a call at the office and we'll step you through it. Anything you do with that sensor before you actually cut it and extend the wire, just tape it away from, tape it to the metal cabinet away from that airflow to see if it's going to change the effects that you thinking it's causing. What else is there? The MD1001 controller, this board is still out there. It's a good board. It's just that the newer models are coming out and, excuse me, they're going to be using the newer style board. All these parameters are the same. It's just that when you press and hold the mode button, the first time to get into the parameters, you won't have to enter a passcode of 66.
Hey, Mark, is it possible to set up the CX5 to turn on based on temperature and flow?
I kind of missed the first part of that about temperature and flow.
Is it possible to set up the CXI fan coil to turn on if there's hot water or cold water coming through it?
Right. It does know that. If your temperature for the mode that you're in isn't within its range, the cooling or heating light will flash. It'll alternate, telling you that the water temperature in the coil is not within range of what your mode is selected. So it won't turn the fan on. It'll just flash at you. Now, I'm glad you brought that up, because if you wanted to check the temperature of the coil, the water going through the coil, you simply hold the up and down temperature buttons on the panel. Just hold them down for 1 or 2 seconds and then release them both at the same time, and it'll show you that temperature of the pipe sensor. So there's only 2 sensors in this fan coil. One of them is the pipe temperature sensor, which looks at the water temperature. The other one is the ambient air temperature that's under the grill. Okay, so it's a pretty simple device, and we're going to come up on the next page showing the actual schematic. Well, I guess we're going to do the remote first. The remote pretty much explains itself. One thing I wanted to point out, though, is there's this sneaky little button that tends to get people. You guys see right in the center of the screen, it says screen LED. John,
Yes.
do you see that? Okay,
Yeah.
if you accidentally press this button in the middle of the night, or if you do it intentionally, it's going to shut off the display while you sleep. A lot of people forget that they did that, and then the next day, it's still asleep, and they think it's broken, but it's not. So anytime you see your screen blank, go try it with the remote and hit the screen LED button once. See if it'll come back on.
Okay.
I get a few calls on that one. And again, the rest of it, you can read the directions for the remote. Batteries, big thing there. Always have a set of batteries in the house. These remotes, if you have more than one fan coil, these are universal. They work on any one. They're not assigned to any particular fan coil. That's good and it's bad. If you have two fan coils together, you're going to have to shield one from the RF, or else it'll change whatever button you're hitting on both of them. And these are all just explanations of the buttons. And here's the MD1001 board. It's the older board. Once this is not produced anymore, it's an easy switch over to the ZLP board. I'm not going to spend a lot of time on this at the moment. We're going to focus on the ZLP board. ZLFP. And let me shrink that down. Okay. On the left-hand side, that's your fan motor. You can see the little E coming off the leftmost wire. That is they call it a sensitive switch. And that's that switch that's in the behind the grill where the air filters are. If that switch opens, no fan, okay? So if it's not the switch, which can be jumpered to see if you can clear that E0, then there's a possibility that the motor's bad. When you're clearing an error like an E0, you have to hit the power button once and then turn it off and turn it on with that power button. That's the only way to clear it. And if you have your finger on that switch and you're power cycling it and the error comes back, you either have a bad switch or it's something with the fan motor. So moving over to the top left of that board, that's where the control panel plugs in. It's labeled controller CN1. There's a CN6. That jumper, I would recommend cutting those wires and twisting them together so you're shorting out the two pins in CN6. That is a terminal that was used to move from slave to master. And once you set it up for master, to keep it there, I would twist those two wires. It doesn't have the effect on all boards, but we've noticed that some of them need those two wires switched. Otherwise, you get some weird problems with these turning on and off. Moving to the next connector, net 1, that's not used by us. Temp 1, that's where your temperature sensors plug in. It's a cable that splits off into two sensors that plug into the end of the cable, pretty much as shown in the drawing. Coming down the board to net 2, that's going to be your Modbus connection in case you're using Modbus for something. It's there and it's available. CN3 is not used. It's an output, not an input. CN5 is not used. It's an output, not an input. For some reason, these little boards can turn a chiller on and off. We don't support it. Just leave them disconnected. The last part of this we're coming to is the actual transformer that I mentioned. It's driven by ACN and out 1. So if you look at the wiring diagram, those two wires are going to go to TC, which is your transformer. Its primary is 120. Its secondary is 24 volts AC. And it's going to power a valve, a relay for a pump, anything that uses 24 volts. The limitations to this transformer is going to be 0.25 amps. So when you're using a relay to power a pump, just use an ice cube relay with a coil current of less than half an amp. I think they're a lot lower than that. But don't forget, it's 0.25 amps to activate a relay. The power to these is going to be a standard 120. You can hardwire it into the connector, or you can put an outlet behind the panel and use a plug as a safety disconnect or a service disconnect. It's completely up to you. If you hardwire it, of course, you got to turn the breaker off. Is there any questions on this? Well, John, I've got about 10 minutes left before I get thrown out of the building.
Okay.
Couple things. Go ahead.
No, keep going.
Okay, so a couple scenarios that we look at when wiring up a pump. As long as these fan coils are on the same side of the breaker, like they're all being pulled off of L1, you shouldn't have any problem powering the relays. You can put all the relays in place, one for each fan coil, and use the output going from one relay to another using this wiring schematic. So any one of these that comes on, it'll power your external pump. So we threw that in just because people like to have these fan coils sometimes on the load side of your buffer tank, which means that you're going to need a pump to pump out of your buffer tank to the fan coil circuit, just as if it's a floor loop. So you can do this any way you want. We just happen to throw this in there, and it works for us.
Okay, so we do have other questions come in. Mr. Purdy's asking one question for the end, and we have a CX50 system with radiant floor heating and DHW. Our DHW tank has a backup heating element and has its own thermostat behind the cover on the tank that ranges from 120 to 90 degrees, slotted screw with arrow and so on. Let's see.
Is he looking at the adjustment for that thermostat?
I can't see quite the end of this yet. Let's see if I can. For some reason, I can't scroll down far enough to see the end of his comments. Oh, here we go. Slot screw with arrow, you rotate. Does the temperature you set it at have any effect on Legionella function? I would say yes on that, the thermostat.
Yeah, that's going to be a secondary. If you're not using Legionella, I would set that thermostat to 120 as a safety feature. If you are using Legionella, you'd have to go up to 140 with it to stop the element. The chiller will also look at the tank temperature too, but it's best to always have one of those thermostats to control your element. And to be able to use that little flat blade, it's a little flat blade screwdriver you're going to use to set the temperature limit. So it depends on what you're doing with it. Normal use, set it for 120. It won't be on unless the chiller can't heat the tank. And at that time, it activates E1. And that's when that element will respond and be controlled not only by the chiller with a power source, but a temperature thermostat that's mounted inside the unit. And one thing I didn't mention, there are little standoffs welded inside these tanks to hold a standard Home Depot thermostat.
Okay. He was wondering if the setting needs to go up to 140, and I guess we've been supplying up to 120. We might have to get them a different thermostat to get to 140.
Right. If you're doing Legionella, you don't want it to stop at 120. So you are going to have to adjust that to 140.
I think these things are kind of relative. I think you can turn it a little bit past the 120 to get your 140, but nevertheless, it's not doesn't have an indicator on the thermostat.
Well, the only time the chiller is going to activate E1 is going to be when it can't reach set point in a reasonable amount of time, or it's really cold outside. That's one condition. The other would be that Legionella, where it's going to deactivate E1 once it hits 140, regardless of that little thermostat. So again, that little thermostat is just a second layer of protection, safety device. And if you're using it for domestic hot water, the chiller set point at the chiller is going to be what it's going to be looking for, that element to reach. So that's when I said, if you're not doing Legionella, I would just set that to 120 as a second layer of protection, just so it can't go over that temperature.
Yeah, that's normally how we do it. But still, to get to Legionella, it looks like we have to get a higher temperature thermostat.
Yeah.
All right. Are there other questions? We've got about 10 minutes tops with Mark here.
Actually, it's about 2 minutes because I got to shut down.
Horacio wanted to talk about tools needed for technicians to, I guess, on the refrigeration side. If you can make up a kind of a list of what is normally used on the refrigeration side, I remember he had a list up here someplace. He talked about refractory tester, R32 sniffer, transfer pump, pressure tester, Freon, how to add Freon. That's actually a whole other ball of wax. You have to get a search, go through some studying and testing to get a refrigeration contractor or tech training, and they will send you a license to do that sort of thing. It can be done online, I understand.
Right. Well, you're talking about the testing, EPA testing?
Yes.
I don't think they're going to let you do it online. I think they actually want you there in person.
Oh.
Otherwise, everybody be taking the test and passing it with 100s. So, anyway, getting back to your first statement, you're going to get a list probably, I hope tomorrow, of all the equipment that I'm going to need when I get there for the refrigeration work. On the other side of that, you can do videos of me doing the parts replacement, because I think you had mentioned a compressor. I know we're going to need an EEV. So we'll go ahead and film some of those for contractors that are asking, well, I never heard of a Chiltrix unit, and I don't know if I want to work on it. And you can show them the video and say, hey, it's just like any other heat pump. You know, it's in a lot of cases, it's even easier. So yeah, we're going to be doing a little bit of everything when I get out there, and I'll get you that list. I actually started it at home. Looking in my garage, I just don't really have much stuff that would help. Maybe I'll buy a special brazing tip, but other than that, you're going to need the full setup for, when I leave.
But I think I probably do have everything, but I'll send you pictures of everything I have.
Yeah.
And I actually did invest in it. It was a few $1,000s to do this. So,
that's your budget?
No, it's already been spent.
Oh, all right. Well, hopefully you got everything. This stuff is not cheap.
No, not at all.
Okay. Well, guys, I've got to get started packing up here. So if you have any more questions that come up later, this class is officially over, but not really over. It's an ongoing thing with our chillers. If you notice anything different than what you saw in this presentation, feel free to take a picture of it and send it to me, and I'll address it as soon as possible. If you have any questions that were outside the scope of anything we talked about today, same thing applies. Give me a couple of days to get the answer. If it's above my head, I'll be going to the factory for a lot of answers to make sure they're accurate. And that sometimes takes 24 hours because they're on the other side of the world. So with that
I'd like
said,
to just say thank you very much.
sure. It was more than a pleasure. And we will have more of these in the future as our newer products come out.
All right. Yeah, they have
Thanks,
quite,
Mark.
I'd like to mention one more thing before Mark goes is they're planning on coming out with a high temperature Chiltrix, about 150-degree outlet temperature, 7.5 tonner. It's in the lab right now, as far as I know, Mark, and the goal is to have it ready for us before the end of the year. So
It's top secret. I can't talk about it. I'd have to kill you.
all righty. Well, with that, thank you so much, Mark. We got a lot of thank you and very helpful. Thank you so much, and so on from the class.
All right, very good. I'm going to go ahead and mute and close down. You guys
Thank
have
you,
a
everybody. See
great
you later.
rest of your day.
All right, thank you. All right, unless anybody else has any more questions for me directly, you can always email me. I think all you guys have my email. So I'll keep it open here for another couple minutes if you want to contact me right now. Otherwise, we'll email me later. And I will. This is being recorded, and we will make it available. Rick, who's been online with us, is going to spend a little time editing it, and Mark's going to send me a lot of those extra manuals so that we can get everybody up to speed with the latest information. All right. Oh, by the way, who is admin? I don't know who that is over there. Can you enlighten me? Who's behind the admin screen there? Anyway, any other comments or questions out from everybody? All right. Well, with that, I guess we'll conclude the recording here, Rick, and I'm gonna say goodbye to everybody. Thank you very much for coming.